Hello everyone, I am Anish and welcome to my channel. So today we are going to do pulse response of all the RC and RL circuits in a marathon session. Okay, so if this video gets enough likes and views, then I will think about keeping this video on the channel, or else I will think about making it private. So it depends on you guys. If you guys support this video, then this video will remain. Okay, so that's it. So first let's start. So here the input voltage, right, it will always be a square waveform in all the cases, and the duty cycle of the waveform will be 50%. And we will solve for two cases: when the time period of the waveform is much less than the time constant of the circuit, and when the time period of the waveform is much greater than the time constant of the circuit. Okay, so in the first example, right, we have a simple RC circuit. So I have already solved it in my channel. Here I will solve it again in just a fast manner. So what will happen, first we are solving for the first case, right, where time period is much less than time constant of the circuit. So the cap won't reach steady state. It won't reach steady state for the initial values, right? So what will happen, let me draw for the initial case at t equals to 0 plus, right? So what is happening, we have one voltage source here, plus minus 5 volts. This is R resistor and this is C capacitor. Okay, and this is the VO. So initially, as there is no initial charge across the capacitor, so the capacitor will become short circuit. The circuit will become something like this, plus minus 5 volts. This is C and this is VO. So there is some finite current, hence the capacitor won't change its voltage suddenly. So what is the finite current? IC of let's say the first instant we are checking, IC of 1 equals to 5 by R, and what is the VO of 1 equals to 0 volt, right? So as this is positive, right, this IC is positive, so the cap will charge, it will slowly charge. Why? Because we know IC equals to C dVc by dt. So as the current is positive, hence the slope of the voltage of the capacitor will be positive, hence the voltage will slowly increase, and it will try to increase to the steady state value, that is towards the 5 volts. So but it won't get to 5 volts because we don't have enough time. The voltage source will become off before it reaches to steady state. So let's say the capacitor charges to some voltage. For example, let's say it charges to 1 volts, right? After that, what happens, the source becomes off. So now what is the current, when the just before the source goes off, right, when the voltage across the capacitor is 1 volts, so this gets replaced by voltage source. So what is the current now? The current in this loop, IC2 equals to 4 by R, right? So as we can observe, the charging rate has reduced. As IC2 has reduced, so the dVc by dt will also reduce, hence the charging rate has reduced. So slowly it will try to reduce its charging rate. So what happens just after this, when the source becomes off? When the source becomes off, we have this voltage, right? So the capacitor won't change its voltage instantaneously, but it can change its current suddenly. That's not an issue. So what is the current now? We are assuming current direction like this, right? So what is the current? IC3, right, equals to minus 1 by R, right, as the current is flowing in the opposite direction. So I hope you can apply the KVL. So we can see it is minus 1 by R. What is IC? IC is C dVc by dt. VC is like this. Okay, so as we can observe, it is negative, so the voltage will try to reduce, right, in the negative slope. So it will try to go to 0 volts. It will try to discharge, but again the same thing, right? We don't have enough time. Again at t equals to T, capital T, the source will get turned on, hence it will get again charged. So here it is minus 1 by R. What is VO3? VOT is minus 1, VO3 is plus 1 volts simply. Okay, and here what is VO2? VO2 is plus 4 volts. Okay, now let's go to the next stage, that is at t equals to T. So it was at t equals to just T on minus, it was t equals to just T on plus. So what is happening at t equals to T on, t equals to capital T? So at t equals to capital T, the circuit again replaces like this. But one thing we need to remember is that this capacitor will discharge, right? So if this capacitor is discharging, hence it will discharge to some value but not completely to 0 volts. Why? Because as we can see, when it was charging, right, the charging current was somewhat like 5 by R, right? It was here, it was 5 by R, but the discharging current is much less, minus 1 by R, but the magnitude of discharging is much less. So hence it won't discharge that much amount, because here how much is the cap charge? The capacitor charge from 0 volts to 1 volts, right? But it won't discharge totally 1 volts, it will discharge somewhat less than the 1 volts. Let's say that the capacitor discharges to 0.5 volts, it discharges 0.5 volts. 0.5 volts. So what will happen now is that, so it discharges to 0.5 volts. So at t equals to t on, right, what will happen? The circuit will look something like this. This has 0.5 volts, this has like 5 volts, this is R. So what is the current right now? What is the current? IC equals to 4.5 by R, right? So IC equals to 4.5 by R. So as we can observe that the charging rate has reduced, right? Initially it was 5 by R, now it is 4.5 by R. Now again the same thing will happen. Now it won't get charged to totally 1 volts, right? Initially what was happening, it went from 0 to 1 volts, right? Now it has some voltage across it, that is 0.5. So it won't get to 1.5 volts, it will get to something less than 1.5 volts, that is let's say 1.25 volts. Okay, so if it goes to something less than 1.5 volts, 1.5 volts, so it goes to 1.25 volts. So what will happen when the source is off, right? It has plus minus 1.25 volts, and we're taking the V0 from here. So what is the current right now? The IC current, right, is negative 1.25 by R. As we can observe here, the IC current has increased in the negative direction. Here it was minus 1 by R, here it is minus 1.25 by R. So the discharging rate has increased. So basically what will happen is that at some situation, at steady state, the charging rate and discharging rate will be equal, right? As the charging rate is reducing and discharging rate is increasing. By discharging I mean with negative sign. So if I meant discharging, it's basically negative sign, but the magnitude of charging and discharging will be equal at steady state. So at steady state, how will the circuit look like? The circuit will look something like this, right? This is C, this is R, this is VI, this is VO, right? So basically one thing we know, at steady state the average current across the capacitor will be 0. Why? Because the voltage across it will be constant. So if the voltage across it is constant, then what we can write is KVL simply, VI equals to I naught times R plus VC, right? So now if I take the average of the whole equation, right, VI average equals to I naught average times R plus VC average. So I naught average will be 0, right? So VI average equals to VC average. So what is VI average? It is basically 5 times T by 2 plus 5 times plus 0 times T by 2 divided by T equals to 2.5 volts. So VC average equals to 2.5 volts. Okay, so what we can say is that this capacitor, right, will ripple around 2.5 volts. Okay, but there will be some charging and discharging slowly, but it will ripple around that. So now if I replace the circuit, right, so here we have resistor, here we have plus minus 2.5 volts, here we have plus minus 5 volts, right? So this is VO. So here what will happen, there is some current, right, there is some current flowing, so the capacitor will try to charge, but obviously as it is at steady state, it won't get charged too much amount, it will get charged slowly to some amount like 2.6 volts, then again, like when the circuit is off, right, circuit is off, again it will discharge to some like 2.6 to it will discharge 2.4, something like that. So but like the average value will remain around 2.5 volts. So the current, right, the current reverses its direction and the average current is 0 through this resistor, right. So what is the current here? The current here is 5 minus 2.5 divided by R, which is 2.5 by R. Okay, and what is the current in, like this is charging case and this is I discharging. Okay, discharging, here it is minus 2.5 by R. Let me change the direction of the like current. This is the current, right. So this is minus 2.5 by R. So now what will happen is we have got the charging and discharging current. Now we can draw the waveforms, right. So if I draw the waveforms, so what is happening here is initially output voltage was 0, slowly it was charging, then suddenly like the source got off, so it slowly discharged, then again the source turned on, so it again charged, then again discharged, and then finally it settled to some value, right, settled to this 5 volts, right, but it will ripple around that, it will ripple around that 5 like sorry 2.5 volts, it will ripple around that 2.5 volts. Okay, so here we have the output voltage. Now how the current will look like? The current will basically be a bit opposite. So initially the voltage was 0, right, so initially it will be let me change this, this should be upper. So initially the voltage was 0, right, so it will go from 5 by R, it will decay, right, from 5 by R it decay to 4 by R, right, we saw this from 5 by R here, like here from 5 by R it decayed to 4 by R, right. So what will happen is it will decay to some value, then again it will go to same that negative value, right, minus 4 by R, then again it will decay, then again here it will go, then again decay, go decay, and this circle will go on, like then what will be this value? This value we have just calculated, this is 2.5 by R and minus 2.5 by R. So the rate of charging and discharging are same, right, as we can observe, this is 2.5 by R and this is minus 2.5 by R. Okay, so the rate of charging and discharging are same, right. So basically we have solved the circuit for the first case. Now let's solve this for the second case, right. Second case where T is much greater than RC. Okay, so if T is much greater than RC, so like the circuit has enough time to charge and discharge to steady state, right. So what will happen? We have this R, we have this C, RC, and we are applying a plus minus 5 volts over here. So what will the steady state voltage will be? It will be like a exponential, right, it will be exponential, like initially there will be some IC of 0 plus, which is 5 by R, and what is VO of 0 plus? It is 0. So what will be VO steady state? VO steady state will basically be 5 volts and IO steady state will basically be 0 amps, right, at or like steady state the gap will be open circuit. Why? Because the rate of change of current is 0, IC is 0, IC is 0, then the gap is open circuit, right, because the rate of change of voltage is 0, the voltage isn't changing. So the circuit will look something like this at steady state. This is VO, right. So if this is VO, this is R, right. So what is the voltage? Like VO is 5. So what is happening? It is going from 0 to plus 5 volts, right. Now what is happening at the like other half when the like input is off? So when the input is off, we have this circuit of plus minus 5 volts because the capacitor has charged to 5 volts, right. So like again this is I and this is V, right. So here what is VO just after T on plus, right, equals to 5 volts, and IO just after T on plus, what is it? It is basically like minus 5 by R, right, it is minus 5 by R. So IO just after T on plus is minus 5 by R. So again what is happening is that at steady state everything will be off, right? The cap will be open and the current through resistor is 0, so voltage across the capacitor is also 0. So VO of steady state equals to 0 volts and IO of steady state equals to 0 amps. So how will the waveform look like? Let's draw it. So the waveforms, right, T. So this will get charged to 5 volts and again like this will get charged very fast to 5 volts, then again it will get discharged very fast, right, because here it is discharging, right? So it will discharge, this is T on, then again it will get charged and then again it will get discharged. This is T, right, and this is T on, sorry, this is like 2 T on. So this cycle will keep on happening. What is happening to the current? So initially there was 5 by R of current, 5 by R of current, then it went to 0 at steady state, then again at T equals to T on, right, it had negative 5 by R of current, negative 5 by R of current, then it went to 0, then again at T equals to capital T, positive 5 by R of current, then it had negative 5 by R of current. So this cycle will keep on going on. So these were the like 4 waveforms for 2 cases. Now let's go to the second circuit. So let's solve for the second circuit. So in this circuit what will happen is that basically we have the same pulse input, right? So what will happen, initially the capacitor will be short circuit. I am solving this for the first case where time period is much less than RC, right? So it won't get enough time to discharge or charge or to reach steady state. So initially the circuit will look something like this. R, this is VI, this is VO. So VI equals to VO initially, right? Then slowly what is the current? IO equals to 5 by R. Okay, basically VI by R. This is the current, right? So as this is the current, so the cap will again slowly charge. Now if the capacitor is slowly charging, it will reach to some voltage like 1 volts VC at T equals to like VC in the VC1, let's say first case, right? So let me draw the circuit when the input is off. So when the input is off, the circuit will look something like this. This is R, input is off, this is 1 volts and some current is flowing, right? What is the current? Current is minus 1 by R. So it is discharging, right, minus 1 by R, but it will discharge to, let's say, from 1 volts it will discharge to 0.5 volts, right? Why 0.5 volts? Because the charging current is much higher than the discharging current, right? So it will discharge somewhat less, so it is 0.5, right? Now again let's draw the circuit. We have plus minus 5 volts here, we have plus minus 0.5 volts here, we have R here, right? So what is the current right now? What is the current? The current is 4.5 by R, right? So here what is happening is that the rate of charging has reduced, right, from 5 by R. Previously it was 5 by R, right? Now this I naught of 2, right, I naught of 2, it is 4.5 by R. This is I naught of 1, V naught of 1, right? So what is happening? The rate of charging is reducing. So now from 0.5 volts it won't go to 1.5, it will go to something like 1.25 volts. Again this will keep on happening, basically like previous question only. So it will reach steady state. So at steady state what will happen? Charging rate and discharging rate will be equal, right? Hence the average current will be 0. So this is the circuit, this is VI, this is VO, and this is like VC, right, plus minus. So VI equals to VC plus VR. So VI equals to VC plus IO times R. Now if I take the average of this equation, VI average equals to VC average plus 0 times R, as I naught average is 0. So VC average equals to VI average. Hence, what is VI average? It is 2.5 volts. So VC average is this, just like the previous case only. So let me draw the circuit for like when the input is on and input is off. It's same only, right? It's same only. This is charged to 2.5 volts, but the like places has been replaced, right? The resistor is in the output right now and the capacitor is towards the input. So this is 5 volts. So what is VO? VO is simply, if we apply KVL, it is 2.5 volts, right? And what is IO? IO is 2.5 by R, right? Like in when input is on. Okay, now when input is off, the circuit will look something like this, plus minus. This is resistor and this is like 2.5 volts, right? And this is VO. So what is the output voltage? This is ground, right? So output voltage is basically minus 2.5 volts, right? And what is the current? Current, the direction we are taking is this one, right? This is the notation. So the current is minus 2.5 by R. So basically as we can see, the current and voltage, both of them ripple around like 2.5 and minus 2.5 by R. Basically, as this is resistor, right, it will just follow the voltage, or current will follow the voltage will follow the current. So how the waveforms will look like? Waveforms of V0, right? Basically what is happening, initially it has some like initially what was happening, VO was 5 volts, right? Initially VO was 5. So initially it had 5 volts, then again suddenly it got changed to like minus 4 volts, right? Here it got changed to minus 4 volts. Why? Because VC1 is 1 volts. So what is the output voltage? Output voltage is taken from here, right? So it goes to minus 1 volts, right? But just before this, what is happening, like in this case, when input is on, here we have plus minus 5 volts. Here this capacitor has charged to 1 volt. Here we have resistor and this is VO, right? So what will VO? VO will be equals to 4 volts, right? VO will be 4 volts. So like let's draw this. This is like around 4 volts. This is 5 volts. This is around 4 volts. Then again it reduces to somewhat like negative 1 volts. Then again it reduces the discharging. Then again here it goes to some like 4 volts. Then again it reduces, and slowly what will happen, it will ripple around this value, right? It will ripple around 2.5 and minus 2.5. okay, this is VO of t and this is t. So it will ripple around 2.5, and here from where it will ripple around minus 2.5 by R and plus 2.5 by R, right? So 2.5 by R and minus 2.5 by R. This is t, this is I of t. So this is how the like waveforms will look like for case 1, when time period is much less than RC. So when time period is much greater than RC, right? Much greater than RC, what will happen? I'm just drawing this a bit fast. We have 5 volts, we have C and R, and this is the VO, right? So like initially what will happen, initially like the current through this will be 5 by R, initial IO 0 plus. At steady state, when the source is on, so the current will be like steady state current will be 0 amps, right? And what will be the voltage in this case? VO of 0 plus will be equals to simply 5 volts, because VO will be equals to VI, and VO of steady state will be equals to 0 volts. Why? Because the current is 0, so drop across this is 0 resistor, hence like it will be 0 volts, right? So again what is happening when the source is off, right? So the source is off, this like capacitor has been charged, right? Here if VO is 0, what is happening, the VC has been charged to 5 volts. So if the VC has been charged to 5 volts, what will happen here is, this is resistor and this is 5 volts. So what is the current? Direction of current is this, right? So I naught like at just after T on plus will be minus 5 by R, and V naught like just after T on is plus is it is minus 5, right? So at steady state what will happen? IO of steady state, this is the case A, this is the case B. When Vi equals to 5 volts, when Vi equals to 0 volts, so IO steady state will be 0, VO steady state will be 0. So like let me draw the waveforms for this. So what is happening, basically initially like what is the VO? Initially VO is 5 volts, so it will go from 5 to 0. It is going to 0 right here, it is going in here it is going to 0, right? And initially the current is 0 amps, so current is sorry, and initially the current is 5 by R, right? So the current will be 5 by R, and it will also reduce, it will just follow the voltage. The voltage is 0 up until T equals to T on, then suddenly changes its polarity, goes in the negative 5 volts, right? So you may say like, why is the voltage changing instantaneously if you have the capacitor as a circuit? But one thing you need to note, where we are taking the output as, we are taking the output from the resistor, right? So current is changing instantaneously, but voltage isn't for the capacitor, but for the resistor it can change, right? So be careful from where we are taking the output from, right? So it is very important to note. Okay, so here again this cycle will continue at capital T, and it will again go to negative 5 and like decay like this. So this is 5 by R, and this is minus 5 by R. Okay, so this is what we are getting. Now let's go for the next circuit. Okay, so the next circuit is really interesting. Here we have R1 and R2 resistor with a capacitor, right? So I will assume that R1 equals to R2 equals to R for the ease of our calculation. So for the first case we have T much less than R1 parallel with R2 times C. Now how am I finding the time constant? Basically shorting the like terminals and then finding the equivalent resistance across the capacitor, right? So this is basically R1 parallel with R2. Okay, now what is happening in the circuit? So initially just when at T equals to 0 plus, how the circuit is looking like? The circuit is looking something like this, right? The cap will be like short circuit because it has some finite current flowing. Why? We are applying here 5 volts and some finite current is flowing. So this has like 0 volts here, so through this 0 amps of current will flow. So through here some amount of current will flow. What is that amount? That is 5 by R. So IC like 0, right? Initially it is 5 by R. So initial charging current is 5 by R, so cap will slowly charge in the positive direction, right? So the voltage will slowly increase. So let's say the voltage increases to 1 volts, right? Now what is happening? What is the V output right now? V output will be same only because we just before the source is getting off, right? We have this 5 volts, this is R, this is R, and this cap has been charged to 1 volts, right? The capacitor. So like this is some current IC. Okay, and this is also like our output current also, which is equals to IO, right? So like what is the output current right now? The output voltage VO equals to 1 volt, right? This is VO, let's say 1. Okay, this is VO 0. VO of 0 equals to 0 volts, right? The capacitor voltage is 0. So VO 1 is 1 volts, let's say. Now what is the current through this? Voltage across this resistor is 1 volts, right? So current through this will be 1 by R. What is the current at this point? The current at this point is 5 minus 1 by R, right? So 4 by R. So how much current is flowing through here? Basically 3 by R, right? So IO is 3 by R. So here 4 by R current is flowing, 1 by R is going down, and 3 by R is current going in the like capacitor 3 by R. So we can observe that this charging current has reduced, right? So the rate of charging is reducing. So now let's draw when the like source is off. When the source is off, this is resistor, this is resistor, this is R, and we have again the capacitor like won't change its voltage instantaneously, it will be 1 volts only. So now what is the voltage output? Still it is VO of 2 equals to 1 volts, right? But what is the current? Here we are seeing that like this voltage is 1 volts, this voltage is 1 volts. So what is the current? Through here also we have 1 by R of current, through here also we have 1 by R of current. So in this node, right, we have 2 by R of current, but in the opposite direction, because we assumed IC to be in this direction, right, in this direction. So let me write the IO. So IO2 equals to minus 2 by R. So we can see that it is discharging, but here what we can observe is the discharging rate is lower than the charging rate, right? It is minus 2 by R. Okay, so like it is minus 2 by R. So what will happen is it will discharge from 1 volts not to 0 volts to somewhat less than like 0, somewhat more than 0 volts, right? So it will go from 1 to 0.5 volts, let's say. So now like what is the VO? It is 0.5 volts, right? So like let's go draw for the next condition, that is here this is plus minus 5 volts, this is resistor, this is resistor, this is plus minus 0.5 volts. So what is the current right now? The current is basically, let me write here, this has 0.5 volts, right? This has 0.5 volts. So the current here will be 0.5 by R. What is the current here? This point is at 0.5, right? This point is at 0.5, this is 5 volts. So current through this resistor will be 4.5 divided by R. So what is the current through that? It's 4 by R, right? So IC of 3, we can say it's 4 by R, right? So it's 4 by R. So what we can see is like initially what was the current here? It was 5 by R, right? Now the charging current has reduced. So basically it will now charge to somewhat less than 1 volts, right? I mean it would, the difference of the charge, right, is basically it will from 0.5, it won't go to 1.5, it will go to like 1.25, something like that. I'm taking the same example again. So it will go to 1.25 again. So if it goes to 1.25 volts again, so what will happen? Basically like if I draw the circuit again, this is plus minus 5 volts, this is R, this is 1.25 volts. So now what is the charging current, right? Again like writing the KCL, what we can see is here we have 1.25 by R, here we have 3.75 by R, so here we'll have 2.5 by R. Okay, so the charging rate has reduced like again. So like again in the like opposite half cycle, like when the input is off, what will happen? This will get replaced, R, this has some voltage, right? this is voltage of 1.25, and like what is the discharging current now? It's basically 2 times 1.25 divided by R, which is 2.5 by R. This is the IO in the negative value basically. So like we can observe that the discharging rate is increasing. Why? Here it was minus 2 by R, here it became to minus 2.5 by R. So discharging rate is increasing and the charging rate is reducing. So at some stage, like they both will be equal and it will reach steady state. So at steady state, what will happen? At steady state, this is our this cap will be open circuit, right? And this is Vi and this is Vo. So if this cap is open circuit, the current through this is 0 amps. The average current through like the capacitor is 0 amps. What is Vi? Vi will basically equals to VR1 plus VR2, right? So like what we can see is, here we have some current, here also we have some current, but if we assume that the average current through the like capacitor is 0, right? I say average, what we can see is, then this VR1 and VR2 will be equal, because I11 IR1 average will be equals to IR2 average, right? So what we can do is, taking the average on both sides, Vi average equals to IR1 average times R plus IR2 average times R. So what we will get is, like IR average equals to Vi average divided by 2 R. So what is Vi average? It is 2.5 as we calculated, so it will be 1.25 by R. So this is the IR average. Now what is the VO average? VO average will be like same only, right? VO average will be this multiplied by R, because we are taking the VO from this point, right? And it is the capacitor voltage. So this is the VO, right? This is R, this is R. So VO will be equals to like IO average into R, which is 1.25 volts. Okay, so VO average is 1.25 volts. So like now let's like see what is the average current, output current. So what is the average output current? So this VO average is 1.25 volts, right? So we can replace the circuit like this. Let me write this calculation of current. This is our, this is some voltage source. This is 5 volts, right? So now what is the current here? IO is basically equals to this one, right? Here what current is flowing? 5 minus 1.25 by R, this is 3.75 by R. Here we are flowing like 1.25 by R. So here we have 2.5 by R, right? So 2.5 by R current is flowing. So basically IO will be 2.5 by R. Again, when the input is off, right? When input equals to 5 volts. Now when the input is off, right? So the input is off. This is R. This is 1.25 volts. This is VO. This is like this is some current, and this is the same current, right? The voltage across it is same. So this is 2I, and basically IO equals to minus 2I, which is equals to minus 2 into 1.25 by R, which is minus 2.5 by R. Like we can see the rate of charging and discharging are same in magnitude, right? So how will the waveforms look like? So basically, like the output voltage, right, it will remain on the average value of 1.25 volts, and there will be some ripples. I'm not drawing the initial value right now. Okay, so initially what voltage we are getting? Initially we are getting almost 0 volts, right? Next it's charging to some value like 1 volts, then it discharges to 0.5, then again it charges to 1.25, then again charges like not 1.25, something less than 1.25. At steady state it reaches to 1.25, right? Steady state it reaches to 1.25 volts, right? So like this is basically the voltage. Now let's draw the current. I had something, yeah, this one. So how the current will look like? The current will basically here we can see that initially it is 2.5 bar, then it is minus 2.5 bar. So like initially what was the current? It was 5 by R, right? Here we can see it was 5 by R. Then again slowly the charging current got reduced and the discharging current got increased. So how will the initial waveforms look like? It will go from 5 by R, then it will decrease to minus 1 by R, something like that. Then again it will decay, then it will decrease, something 4 by R, then here it will increase, then decrease and increase. So at steady state, right, what will be the values? It will be like, let me move this up a bit, it will be 2.5 by R and minus 2.5 by R, right? So at steady state the circuit will look something like this. Let me steady state, it will, let's just revolve around these 2 points, right? Okay, it will just revolve around minus 2.5 by R and plus 2.5 by R. Okay, let's go for the like next case, which is time period is much greater than like R1 parallel with R2 times C. So if they are much greater than this, so it will get enough time to charge and discharge. One more thing I forgot to tell, how can you like tell this intuitively, right? How can we tell this intuitively? So let's like put down the pen and just like see the circuit. Okay, if I see the circuit, what will I observe is that, like first we observe this is a resistor divider circuit. Initially this cap will be short, so whole current will flow through this, the cap will slowly charge. Then when the input is off, the cap will slowly discharge. Okay, but the discharging rate will be less than the charging rate. Okay, but what is happening, we know at steady state the discharging and charging will be same, right? Now if the discharging and charging is same, so what we can do is that like take this cap to the steady state. If the cap is at steady state, the current through this will be 0 amps, the average current. So here whole current will flow, so Vi average will be the summation of this whole resistors in series. So as the current through them is same, average current through them is same, so Vi average will be equals to 2 times VR average. So VR average is equals to I average times R. So I average equals to Vi average divided by 2R. So from there we get what is Vi average, 2.5 by 2, 1.25 by R. So we get the current average. Then from current average we find the like voltage. Here we know the current average, right? 1.25 by R times R equals to 1.25 volts. So the average voltage will be 1.25 volts. Next, from here we can find the current. So this is how like your interview approach should be. But to analyze the circuit thoroughly, I told this like in a like total brief manner, right? So like this is how your interview approach should go. Okay, so next is for the second case, right? T is much greater than R1 parallel with R2. So here what will happen, here it has got enough time to charge and discharge. So let me draw the circuit. This is R, this is C. So I will just solve a bit fast. What will happen, this capacitor, right, initially it will go short as it has no charge, so whole current will flow through the output only, right? This is VO, this is IO. Resistor has been shorted. So this is 5 volts, 5 volts. So what is IO? IO is 5 by R. Okay, so IO is 5 by R, right? So what is VO? VO is 0. Now at steady state, what will happen? This capacitor will turn off, the current through it will be 0 amps. This is R, and here we are giving 5 volts. Now if we are giving 5 volts, right, so what will the voltage, output voltage? It will basically be the voltage divider 5 by 2. It is 2.5 volts. And what will be the current? Current will be 0 amps, right? Steady state. Now let's draw for the case when input is off. So this is R, this is R, and this is plus minus VO. It's charged to VO, the capacitor. So what is it? It is 2.5 volts, right? Because this is the VO. Here we are measuring the VO, so the cap has been charged to 2.5 volts, right? So the cap has been charged to 2.5 volts. This is R, this is R, right? So what is the current? What is the current? Current is basically equals to minus 2 times 2.5 divided by R, which is minus 5 by R. How am I calculating this? This is I and this is I. What is I? I is basically 2.5 by R, right? I is 2.5 by R, and our I naught is this in the opposite direction, but here this is 2I. So that's why it's in the negative direction, right? So what will happen is that basically it's going from minus 5 by R to 0 volts. At steady state, everything will go to 0, right? No current is flowing through this circuit, so everything will go to 0 volts, right? VO will go to 0, no current is flowing. So how will the waveforms look like? So initially what is happening, it is 0, then it is going to plus 2.5 volts, 2.5 volts, then it goes to 0 again, then it goes to plus 2.5 volts, then it goes to 0 again, right? 2.5 volts, right? So what is happening to current? Current is revolving here current is revolving 5 by R to 0, then here again it's minus 5 by R to 0. So basically current will go from plus 5 by R to 0 very quickly, then it will go from minus 5 by R to 0 very quickly, and it will keep on shifting, right? Keep on shifting. And minus 5 by R. This will be the current and voltage waveform. So let's go to the next circuit. So let's start with the next circuit. So we have two capacitors, C1 and C2. So for ease of our calculation, we'll assume C1 equals to C2 equals to C. Okay. So let's first solve for the first case where T is much less than C1 plus C2 times R. As C1 and C2 are in parallel, you can see that, right? The voltages are dependent. So what will happen initially we are applying this 5 volt across here, right? 5 volts across here, and this cap both are shorted. We have this resistor, so current through here will be 0. Okay, but what is happening, some infinite amount of current is flowing right through this loop, so the capacitor will change its voltage instantaneously, right? As if impulse current flows through the capacitor, it changes its voltage instantaneously. So what will that voltage be? The voltage will basically be like a voltage divider, right? This is C2, this is C1, and this is VO. So what is VO? VO equals to 5 times C1 divided by C1 plus C2, right? It will be as capacitor comes in the reciprocal format, so it will be like this. Now in our case, as C1 equals to C2 equals to C, so it will be 2.5 volts, right? So initially, what is the voltage? Initially VO at the 0 state, right, it is 2.5 volts. So what will happen after that? So what will happen is this is C, and we are like applying a VI over here, and we are taking the VO from here, and here also we have one resistor, right? So what will happen is this C, right, it will discharge through this resistor, and this C, right, it will charge because some current will flow in this direction through R. So from here also some current will flow and go to this resistor, okay, but this C will discharge, but this C will charge because current is flowing in the positive of this capacitor, in the positive terminal of this capacitor, and current is flowing out from the positive terminal of this capacitor, so it will discharge and this will charge, right? So at steady state, what will happen? At steady state, like this will be open circuit, right, and this will be open circuit. So current through here is 0 amps, current through here is 0 amps, so current through here will be also 0 amps. The voltage drop across will be also 0 volts, so this point will be converted to like 0, right? So the voltage across the this right hand cap, right, it is 0 volts. So the whole voltage, right, VI will come across this C1 only. So VO of steady state will be 0 volts, but it won't get there because like we have taken the time period to be much less than the time constant. It will try to go to 0 volts, but it won't get there. But VC1 will try to go to 5 volts, right, but it also won't reach to 5 volts. So let's assume that like from 2.5, right, this is 2.5, let me write this a better manner, 2.5. So let us assume this VO, right, from 2.5, VC2 is slowly reducing, right, discharging, so it is going to 2 volts at T equals to T1 minus, right, and VC1, right, it has to go to 3 volts. Why it has to go to 3 volts? Because VC1 plus VC2 equals to VI KVL, right? Just apply simple KVL over here. VC1 plus VC2 should be equals to VI. So we have got the voltages. Now let's draw for the circuit T equals to T1 plus. At T equals to T1 plus, what is happening? Basically this capacitor has some voltage of, let me draw this a correct way, plus minus 3 volts, and this capacitor has plus minus 2 volts, and there is a resistor, right, R, and from here we're taking the upper voltage. What we can observe is, like if we apply the KVL through this loop, it is not validating, right? So some infinite current will flow through this loop, right? Some infinite current will flow through this loop and instantly charge both of these capacitors to same voltage, because they are connected in parallel, so they will be at same voltage. So if I draw this circuit a bit like in a better manner, what I can see is this is minus plus 3 volts, this is plus minus 2 volts, and this is R, right, and we're taking the outer voltage from here. So as infinite current is flowing through, but one thing to observe is that the extra charge that is flowing through here will go through here only, because from here the current is constant, it is 2R, right? The extra charge will go to here. So what will happen, there will be charge conservation law, right? So what we assumed our polarity to be, this is positive, right? VO is in this direction, the output voltage. So initially what is the charge across C1, right? Minus 3 C1 plus 2 C2. I hope you are understanding how I am taking the polarity, because here we assume this is plus minus, so this is negative, right? This is in the opposite direction, so that's why it is minus 3 times C1. C1 is this cap, right? And this is 2 times C2, basically CV, Q equals to CV. And what we are getting at the final, VO equals to C1 plus C2, right? Now C1 C2 are equal to C, so what we are getting, minus 1 by 2. Okay, this is the VO, right? So the VO goes to minus 1 by 2, right? So if the VO goes to minus 1 by 2, what will happen then? Slowly it will try to reach to VO will try to reach to from minus 1 by 2 will try to go to 0 volts, right? because at steady state everything will be like open, because both of these caps will discharge. Both of them have a discharging path through the resistor, so both of them will discharge. It will try to go to 0 volt, but it won't go to 0 volt. So let's say VO goes to minus 1 by 4 volts, right? Now if VO goes to minus 1 by 4 volts, like what will the circuit look like at t equals to capital T plus? So at t equals to capital T plus, right? T equals to T plus. We have input over here 5 volts. This is the cap, this is the cap, this is the resistor R. So now what will happen is, if I apply the KVL, right, the KVL won't satisfy, because like it will be 5 equals to 0. So what is happening? Basically an infinite current is flowing through this loop, right? So the caps will again get instantly charged, but to what value right now? How can we say that? So basically what will happen, let us assume like superposition. So this cap has some voltage of plus minus 1 by 4 volts across it, right? This has already, this C2, right, has plus minus 1.4 volts across it. Now what will this 5 volts try to do? Now if I just assume, take the 1.4 volts as 0, taking the 1.4 volts as 0, now what the circuit would look like? We're giving 5 volts over here. This is C2 and this is C1. So VO equals to basically C1 divided by C1 plus C2 times 5, which is 5 by 2, which is 2.5 volts. So if I assume that the cap is uncharged, it gets to 2.5 volts, right? Now but the cap has some charge, right? The cap has plus minus 1 by 4 volts, but also it is getting to plus 2.5 volts, right? So what will be the actual voltage? The but the cap has initial charge of minus 1.25 volts, right? So what will be VO? VO will be VC like T minus plus like 2.5, right? Plus 2.5, right? So it will be like VC T minus is minus 1 by 4 plus 2.5, so it is 2.25 volts. So now what is happening, the VC is somewhat less than the previous value, right? So it got reduced, but what is the charge across VC1? This was VC2. VC1 will be same only, right? It will be same. Basically it is getting what is like the charge across VC1. This is the charge, right? Plus minus 1 by 4. What is the charge across VC1? This is the charge, right? Plus minus 1 by 4. So if the charge across VC1 is plus minus 1 by 4, and also the like this voltage source, this is also giving it plus minus 2.5 volts, right? 2.5 to both of them. So both of them are in the same direction. So here it will get added. Here it was in the opposite direction, right? So let me show you a bit clearly. Like for VC2, right, what is happening? Like this is giving plus minus 2.5 volts, but we have in the opposite direction 1 by 4 volts. This is for VC2. For VC1, right, this is the circuit. We have plus minus 1 by 5 volts, and also the input is also giving plus minus 2.5 volts. Both are in the same polarity. So VC1 will be equals to 2.75. Also one more way you can look at it is that it should satisfy the KVL. Summation of VC1 plus VC2 should be equals to 5 volts. Now like what we are observing is like the discharging current like has increased, right? So because like this VC1 is increased, so current through the resistor, what is the IR? IR equals to 2.75 by R. So the IR has reduced, right? How? Like this is the voltage to the resistor, right? So if VC1 is increased, IR has increased. So basically the rate of discharging for the capacitor has increased. That is for the C21. So it will discharge to like almost we can say somewhat like 1.75 volts we can say. So what will the input this time? VC2, right? So VC1, what will it be? It will be basically 3.25 volts, right? So how the circuit will look when the input is off? So if the input is off, right, we have this capacitor, we have this resistor C, and the voltage here we have is 1.75 volts, and here we have is 3.25 volts, right? So both of them have like 1.75 volts and 3.25 volts. So what will happen again? Like infinite current will flow. Again we will have to apply superposition. So this time this is the polarity, right, of V0. So plus 1.75 times C minus 3.25 times C equals to VO times 2C. So where VO is going? VO is basically going to minus 0.75 volts, right? So if VO is going to minus 0.75 volts, again it will discharge and the discharging rate will be more again. Okay, so at some point this will reach steady state. What will be that point? When the average current through both of the caps are 0, right? But here what we can observe, if this C2, right, if the average current through this is 0, then it reaches steady state and it opens circuits. So here also through the resistor also the average current is 0, hence the average voltage across the capacitor will also be 0. Okay, only C1 will have the whole voltage, right? Now if I apply the KVL, you will be able to understand. Just let me apply the KVL, right? This is VI. So VI equals to VC1 plus I times R. Now like at steady state the current here is 0 amps, here is 0 amps, so here will also be 0 amps. So the drop across the resistor will be 0. So if I take average, right, VC average will be equals to VI average. So what will it be? It will be basically 5 by 2, which is 2.5 volts, right? And what is the average voltage across the C2? VC2 average equals to 0 volts, right? It is 0 volts because like the current through the resistor is 0, hence the average voltage is 0. So let's try to plot the output voltage. So for that, let us draw the condition for the case where the cap has an average voltage of plus minus 2.5 volts and we are giving here plus minus 5 volts, right? So if we are giving here plus minus 5 volts, this is C and this is R, right? So like what will be the VC2? VC2 will get instantly charged 2.5 volts. So VO will also be equals to 2.5 volts. V equals to 2.5 volts, right? Now basically what is the current, output current? The voltage is 2.5, so the current is 2.5 by R. Rather simple. So what will happen at the negative half cycle? So this is plus minus 2.5 volts, right? And we have the capacitor and resistor. So one more thing, that this is not a capacitor, right? Now we are assuming this has a voltage source because this is some average voltage, right? So this is a voltage source, so here no charge sharing will occur. So this whole voltage, right, will come across this capacitor, so it will be minus plus 2.5 volts, right? So what will be the V0 right now? It will be minus of 2.5 volts. And what will be the I0? So I0 is like this, I0, and V0 is like this. So I0 is minus 2.5 by R. Okay, so basically just this thing is to note that impulse current will flow through the capacitor, right? Because it will get charged to instantly 2.5 volts. So we have got the voltage like for the off time and for the on time. Now let's plot the like waveforms. So what is happening, basically the output voltage, right, initially when the source is on, right, it is 2.5 volts, so it will be 2.5 volts, and it will like decay, right, as the like C2 is discharging here. Okay, it will instantly get charged to 2.5 volts and it will decay. Then what will happen, then it will instantly go to minus 2.5 volts, right, minus 2.5 volts, then it will decay, right, then like because instantly it is going to charge to minus 2.5 volts, then it is decaying through here, right, so it will decay, and this cycle will keep on happening. Okay, so in the current also it will be same, just the replica of the voltage waveform. (2.5 by R and minus 2.5 by R), right. So now one thing to observe is that what is the IC2 current, right, capacitor current. So if I try to plot that current, so let's go to the circuit here. What is the IC2, right, IC2. So when like this case is Vi equals to 5 volts, this case is Vi equals to 0 volts, right. IC2 equal to C dVc by dt. Now we have to do that V final minus V initial divided by del of t times C2, right, this is C2. So what is V final or what is V initial? So V final we know, Vf we know, Vf C2 we know is 2.5 volts, right, because this KVL has to satisfy and this has to get charged to plus 2.5 volts. But what is V initial? V initial is basically the case before this. So case before this is this, right, when the source is off. Now if the source is off, what does this VO go to or VC2 go to? This VC2 goes to minus 2.5 volts. So basically Vi C2 equals to minus 2.5 volts. So what will be the impulse voltage, sorry, what will be the impulse current? IC2 will be 2.5 minus 2.5, that is 5 divided by del of t, so it is 5 C2 times del of t. So this is the amount of charge, right, that is like charging this capacitor, right. So this will be the IC2, and what is the IC1, right, what is the IC2 in the when the input is off. So when the input is off, again we will apply the same formula, basically d Vc2 by dt, which is C2 times this is final minus V initial divided by del of delta t. So what is the initial voltage, right? Initially the previous case we have to go, the previous case is this one, right, it gets charged to plus 2.5 volts. And what is the final state? Final is minus 2.5 volts, right. So I hope you are observing the polarity like minus and plus. So this minus 2.5 volts minus plus 2.5 volts, so basically it becomes minus 5 of C2 times delta t, right. So this is the IC2. Let me write it in a more better manner. Then what happens, then it discharges linearly, right. Now let's draw the circuit, right. When we have input, this is plus minus Vi, which is equals to 5 volts, this is plus minus 2.5 volts, this is this cap is charged to plus minus 2.5 volts, and this is R, right, this is R, and this is V0. So let me assume the direction of the current coming into the positive terminal as positive, right. Generally that's what we take as the convention. This is IC1 and this is IC2. So let me write the KVL. So Vi equals to Vc1 plus Vc2. Now if I take the derivative of this, right, if I take the derivative of this, so derivative of a constant 5 volt will be 0, right, and this is dVc1 of dt plus dVc2 of dt, right? So what we can observe is dVc1 of dt equals to minus of dVc2 of dt. So as in our case the capacitance is same, right? If we multiply C on both sides, C and times C, right? If I multiply C on both sides, what is happening? So as in our case the capacitance are same, so if I multiply C on both sides, right, what is happening? dVc1 by dt times C equals to minus C dVc2 by dt, right? So like we can write this as IC1 equals to minus IC2. Okay, so now like let us write the KCL equation. So if I write the KCL equation, IC1 equals to IC2 plus IR. Okay, now we know what is the IR. IR is basically 2.5 by R, right? Because 2.5 by R is current is flowing. So IC1 equals to minus IC1 plus 2.5 by R. So IC1 equals to 1.25 by R and IC2 equals to minus 1.25 by R. Or you can say that the voltage across both of them are same, so the current will also be same in the opposite direction, because this cap is discharging and this cap is charging. By intuition you can say this, but if you want to prove this like an equation, then you can say this. So IC1 will be 1.25 bar and IC2 will be minus 1.25 bar. So what is happening when input is like 0, right? So when input is 0, we have this plus minus 2.5. Again this is the cap, again this is the resistor. This is basically charged to plus minus 2.5 by R, plus minus 2.5. So again both of them will discharge, right? So what will be the current? So basically 2 IC should be equals to 2.5 by R, right? Because the voltage across both of the capacitors are same, and like the current across the resistor is 2.5 by R, because the voltage across the resistor is 2.5 by R. So IC will be equals to 1.25 by R. So what will the current waveform of IC2 will look like? This is IC2, right? So basically what is happening, as we have calculated, one impulse is coming of 5C2 del of t. So we have one impulse coming of 5C2 del of t, then suddenly it goes to some negative value of minus 1.25 by R, right? Because it is suddenly charging, then it starts to discharge from minus 1.25 by R. So from minus 1.25 bar it starts to discharge, right? Then what will happen at t equals to t on, right? I mean not at t on, at 1000 t on or something like that, like at 1000 much after t on, so 1000 t on. So like when the input is off, what is happening? Again we are getting an impulse, right? So again this impulse is in the negative direction of minus C2 del of t. So this will be the negative direction, which has a area of minus C2 del of t, right? So like this will be the negative direction current. Now again suddenly it's changing to plus 1.25 by 2, plus 1.25 by 2, then again it will reduce, then again we'll have an impulse 5C2 del of t, then again like it will go to negative value, then again it will reduce, and this will keep on repeating, right? It will go to positive value, it will reduce, this will go. So this is the current waveform. So don't worry if you didn't understand this, because they will not ask this in interview, because this is very difficult for anyone to solve, right? So don't worry, this is just to like prove like what is happening in the circuit, right? Very important to understand what is happening in the circuit. Now let's solve for the case where the time period of the signal is much greater than the time constant of the circuit. So what will happen in case A, right? In case A, like the caps will try to short circuit, so there will be some infinite current, right? This will get short circuit and this will get short circuit, and we have one resistor R across here, hence an infinite current will flow. This is 5 volts here, and this short circuit, so infinite current will flow, hence there will be like sudden change in the voltage across the capacitors, and no current will flow to the resistor because it is across 0 volts, right? So it is 0 volts. So what will happen when Vi equals to 5 volts? So basically there will be charge sharing, so Vc1 equals to Vc2 equals to 2.5 volts as C1 equals to C2. So they will get charged to 2.5 volts each. So initially what will happen, they will get charged to 2.5 volts each, and this is resistor R, and this is output voltage VO, right? So now what will happen, slowly again the similar case, this will try to discharge, and again this will charge, this will provide some current here, some current will flow, this will also provide some current, right? So this cap will get charged and this cap will get discharged. So what will happen, what is the VO at t equals to 0 plus, right? 0 plus VO is 2.5 volts, and what is the IO? Basically IO is equals to 0 amps, right? The current through the resistor is 0 initially. So in the second case, like at t equals to t on minus, how the circuit will look like, slowly this capacitor will discharge, this C2 capacitor will discharge, and this capacitor will charge to full 5 volts, right? So what will happen is, this will get open circuit, this will get open circuit, this is the resistor R. Here there is 0 amps of current because here there is 0 and here there is 0, hence the voltage here is 0 volts, right? So at t equals to t on minus, so VO of t on minus equals to 0 volts, IO of 0 minus equals to 0 amps, right? So here in this case what I forgot to mention is that IO just at 0 instant is 0 amps, but IO at 0 plus, right, at 0 plus it will be 2.5 by R, right, because there is voltage across this resistor, so it will be 2.5 by R. So this will be basically the IO. Now what happens after t on, when case B, right, when Vi equals to 0 volts. So Vi equals to 0 volts, how the circuit will get replaced by is, this is 0, this capacitor has been charged by 5 volts, and this has 0 volts, right? This has 0 volts, this is C, and this is R. So again what will happen is, again there will be charge sharing, right, because this 5 volts will share charge with this capacitor, because there will be suddenly infinite current flowing through this loop, right? So what will be the charge across the capacitor? Basically it will be initially what charge we had, 5 into C, right? Now it has some voltage V into C1 plus C2, which is basically C, so V equals to 5 by 2, which is 2.5 volts. So VO initially is 2.5 volts. Again IO here is also 2.5 by R in the negative direction, right? So how does this circuit get charged? So here it charge something like this, right, in negative direction. Just be careful of the direction. Let me replace this voltage source with a capacitor. 2.5 in the negative direction, okay? So just be careful with the polarities. This is R, so this will be negative. So we have assumed I0 to be this one, but how is the current flowing? Current is flowing like this, right? Current is flowing like this. This is 2.5 volts. So this will also be negative. IO will also be negative. It is also negative, right? So both of them will be negative. Now what is happening at steady state? So at steady state the circuit will get replaced like this only, right? Everything is 0. No current is flowing here, no current is flowing here, so no current is flowing here also. So the VO of T minus, right, equals to 0 volts, IO of T minus equals to 0 amps, right? at steady state, right? So like this is initially, this is steady state. Now let's like draw the waveforms. I've drawn like the voltage waveform, right? So initially what is happening, it is going to 2.5 volts, right? So here suddenly there is change of 2.5 volts in this case, and the current is 0 amps, right? But then the current changes to 2.5 by R suddenly because the voltage appears here across it. So this voltage source goes from 2.5 to 0, like shown, 2.5, sorry, here 2.5, then it goes to 0, then again it goes to negative, then again it goes to 0, right? So again negative, then 0. This is T on, this is T, right? And this cycle repeats. This cycle repeats. And for the IO, right? So initially IO was minus 2.5 by R, sorry, plus 2.5 by R, right? Here initially I was plus 2.5 by R, then it went to 0, then again minus 2.5 by R, then it went to 0. So basically it is like same as resistance, right? Basically proportional to resistance. So plus 2.5 by R minus 2.5 by R, like this. So like how will you do this with intuition, right? So what is happening here, basically just think in your mind. Initially what is happening, like some infinite current is flowing, right? Because this cap both become short, so infinite current will flow, instantly charge these two caps. There will be voltage divider, as like they are same C1 and C2 are C, so equal voltage division. Then what will happen, like current will flow here and this will discharge through this resistor, right? This resistor is helping it discharge, but this capacitor doesn't have any discharge path. Current is flowing through here and only it is charging, so this will get charged to 5 volts steady state. It will get, because we have time period much greater than 2 RC. So this will reach steady state and this will discharge totally through this resistor, right? So this is for the first half cycle. Then the next half cycle, what will happen, basically then like this has been charged to 5 volts, this will come in parallel with this, again charge sharing will happen, both of them will get to minus 2.5 volts, then this will discharge and this will also discharge, right? Both of them will discharge with currents like 1.25 by R, right? Both of them will give equal currents. So this is how you will think in like in your head. So this is the intuitive approach. Now let's go to the next question. So here like we have a bridge circuit like structure. Now let's replace this structure with our ease, so that like we can calculate it easier. Let's name this 1 2 3 4. So now this is 1 and 4, then we have register, sorry, I am taking the position. So now this is 1 and 2, and this is the capacitor, this is 2 C, this is C, this is 4, and this is R, right? R C. So and here we are giving the VI. Okay, so this is how we will replace the circuit. Basically now calculate it like two independent circuits. Okay, so how we will do it, basically what we'll do is, first like case A, right? Case A, when VI equals to 5 volts. So if VI equals to 5 volts, like this is 5 volts, right? So I have solved like RC and CR, both of them. So I won't solve it here again. I will just like write the values how it will get. So basically this is a square pulse, right? So what is like VO? VO equals to V2 minus V4, right? Now what is V2 like here? Now let's find the V2 average, right? What will be the V2 average? Like at steady state, like this is a square pulse, right? And these are connected in parallel. So at steady state what will happen, the average value, like average voltage of this will come across the capacitor, because cap will get open circuit, zero current will flow through here, the average voltage across the resistor is 0, hence this will get the average voltage, right, of the input. So V2 average equals to VI average, right, which is equals to 2.5 volts. I hope like you got this. And what is like V4 average? What is V4 average? So V4 average is basically equals to like the drop across R. So drop across R will be 0, as it is like IR average times R, and this is 0 amps because like IC average is 0, like okay, like I have mentioned it in my like previous question, so I won't explain it here again. So it will be 0 volts. So V4 average is 0 and V2 average is also 0. So let me replace when like input is like on. So how will the circuit look like? This is R, this is the voltage source of 2.5, the capacitor is being replaced with 2.5 volts, and we have voltage source here. And this capacitor is also replaced by 2.5 volts, right? This will also get charged to 2.5 volts, and this is R. So how is the circuit looking here? So basically, what is the current through this? It is 2.5 by R, right? And what is the current through this also? 2.5 by R. So we are taking the outputs from this 2 and 4, right? So what is V2 right now? V2 right now is 2.5 because the voltage source is connected. As the current across the capacitor is positive, what will happen is it will try to charge. Now this will increase, right? Like as IC equals to positive, it will increase, right? So what will happen? This will try to increase to some value like 2.6 or something. And what is V4? V4 is basically this is 2.5 by R, so it is 2.5 by R. Let me write this more better manner. It is basically I times R, right? IC times R, which is 2.5 by R times R, which is 2.5 volts. Okay, so it is 2.5 volts. So now what will happen? Basically, like this is 2.5 volts, but as this capacitor is charging, right? This is also charging as IC is positive. So VC, like this VC, right? Let me name this like this one, right? This is like VC2. It is as VC2 is charging, the voltage is getting increased, hence the IC will reduce, right? IC will reduce. You can check it for yourself. If VC is increasing, then the IC will reduce, right? So if IC is reducing, hence V4 will reduce, right? So V4 is reducing with time, and like V2 is increasing with time, right? V2 is increasing. So what is VO? So let is so VO equals to V2 minus V4, right? So as like V2 is increasing and V4 is decreasing with time, overall VO will increase. So basically by this what I mean is what is VO at this instant, right? V2 is 2.5, right? And V4 is also 2.5. So 2.5 minus 2.5 equals to 0, but it will increase around the 0 value, right? Here, like as we see, this is come as 0 value, but it will slowly charge to some value like around 0. It will repel a bit, so it will increase. Then let's do for the case when Vi equals to 0. So Vi equals to 0, right? We have the circuit R, this is plus minus 2.5 volts. So like what is the current right now? So from this the current is through this, because this is 0 grounded, right? So this current is what? 2.5 by R. If I apply KVL, I will get it. Also this current is what? 2.5 by R. So what is V2? V2 is again 2.5, right? And this time, like as IC is negative, because current is leaving from the positive terminal, right? As IC is negative, like this is IC. Okay, so as it is leaving, so V2 reduces. Now for V4 also it reduces, but from where? What is V4 right now? V4 is minus times 2.5 by R times R, right? Because V4 we are taking from here and it is in opposite direction. So V4 is minus 2.5. V4 will also reduce as IC is like negative. IC here is also negative. So as IC is negative, V4 will also reduce. Now what is VO? VO equals to V2 minus V4, which is equals to here in this case V2 is 2.5 and V4 is minus 2.5. So V2 is 2.5 minus 2.5 equals to 5 volts, right? So VO is 5 volts. But what will happen to VO? As like V2 V4 both are reducing, so VO will also try to, like, this is reducing, right? And this is reducing. Let me mark this. This is reducing and this is also reducing, but this is going towards like negative reducing, right? So how can I write this? Basically, if I write this, right, 2.5 plus 2.5, right? So like as you can see, this value 2.5 is also reducing, this 2.5 is also reducing. So overall net VO will also reduce, right? From 5 volts it will also reduce. So how will the voltage look like? So basically it starts from 0, then it increases, right? Then suddenly goes to 5 volts, then again it decreases, then again it goes to 0, increases, goes to 0, then increases, then again it decreases, and this cycle repeats, right? So what is the voltage level here? It is basically 5 volts, right? So as we can see, like if I find the average value of this, right, VO average, like if we assume this is straight line, so VO average equals to 2.5 volts. From here also we can calculate, right? So here, like as we calculated here in this case, like this one, right, what is VO? V2 average is 2.5 and VO average, what is V4 average? It is 0 volts, right? So also we can write this as basically VO average equals to V2 average minus V4 average, which is equals to like this is 2.5 minus 0, which is 2.5, right? So from there also we can get and verify that our waveform is correct, right? So this is how you verify. Now like how should be the like intuitive approach? Like I told you, like this is the intuitive approach only, just thinking about like 2 as a parallel and then solve it. Else you have to solve it like the rigorous manner in which I solved the previous circuits, right? Now let's solve it for like t much greater than RC. So if t is much greater than RC, what will happen? Let me draw for when Vi equals to 5 volts. So this is 5 volts, and again I am drawing the circuit. This is 2, this is 4, right? So what is happening? Like I'm just telling you in a fast manner. This capacitor will initially will have 0 VO of like sorry, not VO, V2 of 0 plus will have 0 volts, V4 of 0 plus will have 5 volts, right? Why? Because the capacitor will get short circuited, this one, right? This one will get short circuited, hence like whole voltage will come across the resistance. Now what is V2 of T on minus, right? V2 of T on minus, what will happen? Both the capacitors will get open circuit because they will reach steady state. Hence what will happen? The circuit will look something like this. So what will be V2? V2 will be basically this whole voltage, right, across the input, because here we have 0 amps of current, here also we have 0 amps of current, so this is 0 volts, right? So V2 equals to 5 volts and V4 equals to 0 volts, right? So if what is VO? Equals to V2 minus V4. So what is like this 5 minus 0, which is equals to 5 volts, and here what is like VO 0 plus, right? It is basically minus 5 volts, right? So like this is let me write this properly. VOT, write this properly. VOT on minus. So this is VO T on minus, right? T on minus. So like as you can see, like VO T on minus is almost 5 volts. Now what is happening is that let's, when case B, let's do 0 volts, this is charge to plus minus 5 volts, right? And this is charge to plus minus 5 volts. So now what is happening, both of the capacitors are discharging, so they will discharge and reach steady state basically through this short circuit path, right? So here what will the current, basically this is 5 by R and this is 5 by R, this current will be 10 by R, right? So like that's how you will solve it. Like VO, where it will reach VO at T on plus, what is it, basically V2 of T on plus minus V4 of T on plus, right? So what is V2 of T on plus? Basically V2 of T on plus is basically 5 volts, right? It isn't changing. But what is V4 of T on plus? V4 of T on plus, as some current is flowing through here, 5 by R, right? So what is the drop? It is like this, 5 volts. So V4 of T on plus is minus 5, right? Minus 5 volts. So VO will be 10 volts at T on plus, and VO of like T minus, right, it is 0 volts, because everything is getting discharged. So like the capacitor will get open circuit, current will be 0 and the voltage will also be 0, right? Why? Let me draw the circuit basically. So the circuit will look something like this. This is R, this is open circuit, this is open circuit, this is R, right? So like if I assume this is VC, right? If I assume this as VC, so this current is 0 amps, right? So VC plus 0 times R equals to 0, as this is short circuit. So VC will be 0 volts. So like everything is 0 volts, so VO will be also 0 volts. Here I have written it, yeah, VO will be also 0 volts. Let's now draw the voltage waveform. So initially it is minus 5, right? Here initially VO plus 0 plus is minus 5, then where it going, it is going to plus 5, then where it is going to then plus 10. Suddenly there is certain change, because due to this resistor there is certain change, not like there is capacitor. Okay, just be mindful of that. Capacitor won't change its voltage suddenly, but due to resistor it is helping. Okay, so up until T equals to T on, right, this is 5, this is minus 5, then what is happening, then it is suddenly increasing to 10 volts, then suddenly it is getting decreased to 0 volts, right? This is T on, this is T, then this is from minus 5, this is going to like this, then increasing and then decrease, right? So this waveform will go on. So this will be basically the answer for this question. Let's go to the next question. So this is the next question. Here let us assume C1 equals to C2 equals to C. Now what will be the initial case, right? So for case 1, right, when Vi equals to 5 volts, how will the circuit look like? Initially what will happen, like as there is no charge across the capacitors, they will get short circuit. So we have 5 volts here, so it will be, what is the current? As the current is finite, hence there will be no sudden change in the voltage. So IC equals to 5 by R, and also like plot the IO, right? This is the IO. So IC equals to IO equals to 5 by R initially, right? So there is some positive current, so this is positive, right? So C charges, okay, C will charge as this is positive. So slowly the capacitors will charge. So what will happen, let's say it's charged to like 1 volts, both of them. So if they both charge to 1 volts, right, plus minus 1 volts, we have plus minus 5 volts. This is R. So what is the IC now? Right now the IC is 5 minus 2 divided by R, which is 3 by R. So IC is reduced, IC reduces, so the charging rate reduces, right? So like it is slowly reducing. Now let's write for the case when Vi is 0 volts. So if Vi is 0 volts, basically this will be plus minus 1 volts. This is R, this will be plus minus 1 volts. So what will be the current right now? We have assumed IC to be in this direction, but current actually, what is the current? Current is flowing in the opposite direction. So IC equals to minus 2 by R. So if you couldn't understand, let me write it, like write the KVL. So if I write the KVL, right, plus 1 plus I times R plus 1 equals to 0, right? If I go from this side, so I is coming as minus 2 by R, same thing only. So IO is also this and IC is also this. Now is IC is negative, right? IC is negative, so what will happen? It will like decay, right? It will decay, so it will discharge. So the capacitors will discharge, and here the rate is minus 2 by R, here the rate was 5 by R, so it is something less, so it will discharge something less, let's say 0.5. Now both of them has 0.5 voltage, and this is the resistor, and this is 0.5, and this is C. Again we have input voltage like 5 volts, right? So input voltage is 5 volts. So what is the current right now? What is the IC? IC equals to 5 minus 1 by R, 5 minus 2 times 0.5 divided by R, which is equals to 4 by R, right? So IC equals to 4 by R. So the charging IC has reduced, so charging rate has been reduced. Now obviously it won't get charged to, like it got charged from 0 to 1 volts, it won't get charged to that, it will get charged to from 0.5 to 1.25 volts, right? Again in the next negative half cycle there will be some discharging, which will increase, right? Here charging is increasing, charging rate is decreasing, charging rate is decreasing. Okay, now what is the like discharging circuit? So as it line, so like the input is off right now, and this is plus minus 1.25, this is R, and this is plus minus 1.25, right? So if this is plus minus 1.25, so like what is the current? IC is minus 2 times 1.25 divided by R, which is minus 2.5 divided by R, right? So we see that discharging rate has reduced. So initially it was minus 2 by R, now it has gone to minus 2.5 by R. So like it will discharge from 1.25 to not exactly like 0.75, it will discharge from 1.25 to let's say 0.85, right? And this cycle will go on like until how long? You know the answer, basically it is until when charging and discharging are equal. So what is the condition? Let me write the input, right? Let me draw the circuit. This is C, this is R, this is C, and here we are applying Vi, and from here we are taking the Vo. Okay, this is C. So what is Vi? Vi equals to Vc plus IO times R plus Vc. Now both of the Vc's are same because same current is flowing through them, right? Hence the Vc is same, and the capacitance is also same, that's why. So like what is the average? Vi average equals to 2 into Vc average plus IO average times R, right? So a steady state, obviously the average current across the capacitors will be 0, hence this will get cancelled to 0, right? This will get cancelled to 0 amps. So Vi average, what is it? It is 2.5 volts, right? Equals to divided by 2 equals to Vc average. So Vc average will be equals to 1.25 volts. Okay, so Vc average is 1.25 volts. So let us to find the VO and the IO, right, for two cases. Let us draw for the cases when Vi is 5 volts. Let me draw the circuit. This is 5 volts, this is plus minus 5 volts, this is the resistor, sorry, this is not 2.5, this is 1.25 volts, and this is also 1.25 volts, and this is the resistor, right? So if this is the resistor, what is the current flowing in this circuit? What is the IO? So IO initially 0 plus equals to, let me not write this like this, let me write this IO initially. What is IO? So in this case, initially IO is 5 minus 1.25 times 2 divided by R, which is 2.5 by R. And what is the VO? VO is basically this IO times R plus 1.25, right? So IO times R is 2.5 by R into 2, or into R, which is 2.5 plus 1.25, which is 3.75 volts, right? So it is 3.75 volts, right? So we have got the VO initially. What is the VO when this Vi is off, right? And what happens to this VO right now? So basically we see that this IO is positive, so this will charge, IC is positive, right? So VC will increase, right? So if VC increases, IO will reduce, but VC increases, right? So if VC is increasing, what will happen to the output voltage? So the output voltage can also be written as 5 minus VC, right? So if VC is increasing, VO will reduce, right, as 5 minus VC is increasing. Okay, so we can also write it like this also. So it will slowly go down from 3.75, but it will obviously not go down very much, very low amount. So what is happening in the second case, right? In the case B, when Vi equals to 0 volts, this is 0, this is plus minus 1.25 volts, this is resistor, this is plus minus 1.25 volts, and this is R, right? So what is the current right now? IO is this, right? So IO equals to minus 2.5 by R. I hope you can apply the KVL. And what is VO? VO is minus 1.25, or you can say equals to minus of VC, right? So what is happening here? It is discharging, IO is negative, so VO reduces, right? So sorry, not VO, VC reduces, right? So if VC reduces, VO will also reduce, okay, as VC reduces, right? So now we can plot the output voltage. So here we have the output voltage, right? VO and T. So initially what was the voltage? Initially we had this case, right, when it was 3.75 volts. From 3.75 it got to reduce, then it went back to minus 1.25 volts, right? Then also it tend to reduce, so this will tend to go like this only, okay, 3.75, and this is minus 1.25 volts, okay. So this will repel around this only. Now what is the current? Current is simple here. What is IO? IO is minus 2.5 by R, and IO will as VC is reducing, IO will also reduce, right? So as this is a source free network, and here as it is charging, IC will reduce, right? Why? Because the voltages across the capacitors are increasing, hence IC will reduce as VC is increasing, right? So IC reduces from 2.5 by R, and it ripples around 2.5 by R and minus 2.5 by R. So let me draw the waveform. So it ripples around 2.5 by R and minus 2.5 by R, 2.5 by R and minus 2.5 by R. So it ripples around that only, okay. So now what will happen? We can cause verify is our output voltage correct or not? What is output voltage? It is basically IO into R plus VC, right? So if I apply the average, VO average equals to only VC average, right? So what is VO average from this waveform? It is basically 3.75 times T by 2 plus minus 1.25 times T by 2 divided by T, right? Which comes out to be as basically almost 2.5 divided by 2, which is 1.25. So like, and VC average is 1.25, which is equals to VC average. So we can cross verify this, that our answer is correct, right? So and the what is IC average? IO average is 0, right? So like, this is how we do this circuit. Now what will be the like intuitive approach? Obviously what you have to do is think in your mind that like initially what is happening, both of these caps are getting short circuited, hence and finite current is flowing, so the voltage across them won't change instantaneously. Then what we'll think is slowly both of these capacitors will charge, and then again when this is source free, input is off, then slowly they will discharge. At some point of time, charging and discharging will be same, and as they are in series and as the like capacitance value are same, C1 C2, hence like both of them will be divided between their average voltages, right? What is VI? VI equals to 2 VC average, right? As the average current is 0, so drop across the R is 0, so VI will be 2 VC average. What is VI average? 2.5 divided by 2, you get VC average. If you get VC average, then from there you will find everything, right? IO and VC. So that's how you should think. So next what we should do is go to the next case, that is for time period of the waveform much greater than the equivalent capacitance times R, that is time constant. So like, let me draw the circuit. We are applying plus minus VI, right? So this was the case when VI equals to 5 volts. So this is the capacitor, this is resistor, C. So this is rather easy. So what will happen is, so there is some charging current. Initially IO equals to 5 by R, so it is some positive value. Then it goes to IO dash, which is equals to 0 amps, because both of them settle, both the capacitors, hence it goes to 0 amps as they become open circuit, right, at steady state, as both of them have enough time to reach steady state. Okay, so from here it is 0 amps, from here it is 0 amps, right? So both of them has enough time. So like, now what is VO, right? VO is basically this 5 volts, right? Because this capacitor is getting shorted, so VO is initially it is 5 volts. Now what does VO change to? VO change to basically this voltage, right? This is the VO. Here the current is 0 amps, right? Current is 0 amps, so VO will be equals to VC only, right? This is plus minus VC. What is VC? VC is 2.5, right? 2.5, because like both of them are dividing equally as the current through them is same, right? So both of them will get charged to 2.5, so VO will get reduced to VO dash at 2.5 volts, right, from 5 volts. So this will be when like input is on. Now when input is off, right, when input is off, right, so what is happening? This is shorted, this is replaced by like let me draw the capacitor only. 2.5 volts, this is plus minus 2.5 volts, and this is R, right? So what is happening? Basically some current is flowing, right? My IO direction is this only, okay, but current is flowing in the opposite direction. So what is IO? IO is equals to minus 5 by R, okay. So this will again like discharge. This is a source free network, obviously it will discharge to 0 volts. So at final stage IO dash will go to 0 amps, and VO dash will also go to 0 volts, right? Everything is like a source free, so it will go to 0 volts. Now what is VO initially? VO initially is basically minus 2.5 volts, right? Why? Like this is the VO, right? Like simply if I apply KVL here from ground, I will get minus 2.5 volts. Or like you can apply KVL as like this also, IO times R plus 2.5. Here also if you put IO minus 5 by R, you will get 2.5 volts, right? So VO is going from here to here. So let us draw the like waveforms for VO and IO. So what will be the VO? VO initially what was it? It was basically 5 volts, right? From 5 volts it went to 2.5 volts. So very fast, from 5 it will go to 2.5. 5 to 2.5, right? Then at t equals to t1 it went to minus 2.5, right? Like here it went to minus 2.5, so again it will go to minus 2.5, then it will very fast go to 0, right? As it is a source free network, and this cycle will keep on repeating. Okay, so what is the current here is basically like initially what was the current? 5 by r, then it went to 0, then again minus 5 by r, then it went to again 0. So 5 by r to 0, then minus 5 by r, then it went to 0, then 5 by r, then it went to 0, then minus 5 by r, then it went to 0, right? So this is 5 by r, this is minus 5 by r. Okay, and this is the current. So one thing what we observe is that, like, if we see the this waveform and like this waveform, right? Now as I told you, like, the method of compression, now if you compress this, right, if you compress this, you will observe that this is coming like this only, right? The waveform is coming like this, but obviously the values are different because it triples around some value. So like if you observe, like, the compression method works like almost every time. Here also if you compress this waveform, right, you will get this voltage only, like negative and positive same amount. So here also the compression method works. Okay, so like this question is solved. Let's solve the next question. So now we will solve few RL circuits. So in case of RL circuits, right, you have to always keep this in mind, that always take help of current. Okay, like for RC, right, we always use the voltage to like understand anything, right? Here we will take help of the current, right? So for this simple RL circuit, what we will do is, like first let's solve for the case when t is much less than L by R. That is, the circuit won't settle, right? So the circuit won't get enough time to settle. What will happen is, initially, like case A, when Vi is 5 volts, right, what will happen? The inductor will be open circuit, right? And here we have 5 volts and this is 0 amps. As the inductor is uncharged, there will be no flow of current. So this whole 5 volts, right, will come across this inductor, as there is finite voltage across the inductor, so the inductor won't get charged suddenly, right? Hence initially what will be the VL is like 5 volts only. Hence slowly the inductor will get charged, as VL equals to L TIL by dt. So VL is positive, right? VL is positive, hence slowly the current will increase. Okay, so slowly the current will increase to what? It will try to reach steady state, that is up until 5 by R. Okay, try to reach steady state, but it won't let reach steady state because we don't have enough time for the circuit to reach steady state, right? So inductor won't get short circuit. So let's assume that the inductor charges to some current 1 by R, right? Because what is its steady state current? 5 by R. But let's assume like it won't get totally charged to that, it will get charged to 1 by R. So let's draw the circuit for that. Plus minus 5 volts R, 1 by R. Okay, so if it gets charged to 1 by R, then what will be the voltage across this inductor? So 5 equals to I times R plus VL, right? So 5 minus I is 1 by R times R equals to VL. So VL is 4 volts. So as we can see, VL has reduced, right? From 5 volts it has reduced to 4 volts, that is the charging rate is decreasing. Now let's draw for the case when Vi is 0 volts, right? So if Vi is 0 volts, what is the circuit look like? The circuit is something like this. The inductor still has 1 by R of current, as it won't change its current suddenly. This is R. So what is the voltage? VO. VO is like this only, right? So from this, VO is VL basically. So if I apply KVL, VO will be minus 1, right? 1 by R times R, which is equals to minus 1 volts. Okay, here VL is minus 1, which is negative, hence IL will reduce, right? So IL reduces, to where it will like try to reach. It will try to reach to totally 0 amps of current and 0 volts, right? But it won't reach there. Why? Because like it doesn't have enough time. So let's assume that it reaches to 0.5 by R of current. So let's again do the same analysis for again if Vi equals to 5 volts. Again do the same analysis. So here we have plus minus 5 volts. This is R. This is like 0.5 by R. Okay, so what is the VL this time? So like 5 equals to 0.5 by R times R plus this VL, right? So VA equals to 4.5 volts. So VL goes to 4.5 volts, right? So like as we can see, the charging of inductor has reduced, right? Initially it was 5 volts here, now it went to 4.5 volts. So charging got reduced. Now what we need to see is what is happening to discharging. So like initially it went from 0 to 1 by R of current, right? Now it has 0.5 by R of current, so it will go to somewhat like 2.5 by R, just the same case as like previous one. So like now what will happen is that if I like draw for the case when Vi equals to 0 volts, right? So if Vi equals to 0 volts, what is happening? This is R, this is the current which is 1.25 by R, this is R, and this is VO, right? So what is VO? VO is basically minus 1.25 by R times R. Our conventional directional current is this, and the drop across the resistor is this, right? But VO is on the negative side, so VO is negative. That's why we are getting minus 1.25 volts. Okay, so VO is minus 1.25 volts, but previously in that case what was it? It was minus 1 volts. So charging is increasing, discharging is increasing and charging is reducing. So at some stage they will equate each other, and then like it will reach steady state. So for that, what will happen for steady state? What will happen? Basically the inductor will get the average voltage across the inductor will be 0, right? So if the average voltage across the inductor is 0, let me draw the circuit. This is R, this is L, and this is Vi, right? And this is VO. So what is Vi? Vi equals to IL times R plus VL. If I take the average of this whole equation, right, Vi average equals to IL average times R plus VL average. So we know that VL average is 0, right? So Vi average is 2.5 equals to IL average times R plus 0. So IL of average equals to 2.5 by R. Okay, so IL average is 2.5 by R. So next what will happen? Basically if we draw the circuit for case A, right, when Vi equals to 5 volts, so the circuit will be replaced by this plus minus 5 volts. This is R, this is 2.5 by R of current, and this is VO, right? So what should be VO? VO here should be basically equals to like 5 minus 2.5 by R times R, right? Just apply simple KVL. So if I apply KVL, minus 5 plus 2.5 by R plus VO equals to 0. So from there we get this equation, right, here. So like what is VO? It is 2.5 volts. So as VO is positive, which is equals to VL, so this is positive, right? So IL will increase. IL is slowly increase. Now if IL increases, what will happen to VO? This is the IL, right? VO equals to 5 minus IL times R. So if IL increases, right, if IL increases, then VO will reduce. So VO will reduce. Now what is happening in the like case B? So in the case B, right, where Vi equals to 0 volts. So this is 0 volts, this is R, and this is again 2.5 by R, right? So this is 2.5 by R, and this is VO, right? So what is VO? VO is basically minus 2.5 by R times R equals to minus 2.5 volts. Okay, so it is minus 2.5 volts, and so like we get minus 2.5 volts. So what is happening? This is discharging, right? As VL is negative, so IL will reduce, hence it will discharge. Okay, so IL will reduce. So what is happening to VO? VO will also reduce, right? As the drop across the like resistance is reducing. VO equals to minus of IL times R. So VO will also reduce. So like and what is the like output voltage we found? So let's draw the waveform for this, right? So if I draw the waveforms, so like now if you draw the waveforms, right, what is IO? IO is around 2.5 only, right? IO here is 2.5. IO here is increasing, right? IL is basically IO which is increasing as like this is charging, right? And the VO is reducing, but IO is increasing initially. And here what is happening to IO? IO is reducing here as this is source free network. So it will ripple around 2.5 by R, but here it will slowly increase, and here it will slowly decrease, increase and decrease, right? So like this will happen. Okay, now what is VO? VO basically here it is 2.5 volts, right? But VO is reducing, right? VO is reducing. Here what is VO? Negative 2.5 volts. Again VO is reducing towards 0, right? So from plus 2.5 volts to reduce, again from here minus 2.5 volts it will reduce. Okay, and this will keep on happening. Okay, so this is 2.5 volts and this is minus 2.5 volts. Okay, here we can see the average voltage is 0 and the average current is a constant current as this is across the inductor. Okay, just keep this in mind. So like initially I told you the case, initially it just slowly the current charges, right? Current slowly charges. So initially what is the waveform? Initially, right, slowly the current, right, it will charge, then again discharge, then charge, then again discharge, then charge, and at some point of time the charging and discharging will be same, hence this is reaching steady state. Okay, here the charging and discharging is same. So like let's solve for the case when like T is much greater than L by R. So I'll solve this a bit quickly. Here we have like voltage source, right, plus minus Vi, this is R and this is L. Okay, this is R and this is L. Okay, so what will happen? This inductor will basically reach steady state, right? VO. So what is VO of 0 plus? It is basically total 5 volts, right, equals to Vi only, because no current is flowing. IL of 0 plus is 0 amps. And what is IL of T on minus? It is basically 5 by R, right? Vi by R. So what is like VO of T or minus? Basically 0 volts. Let me draw the circuit here. This is plus minus 5 volts. This is R. This is shorted. R. This is VO. Okay. So VO reaches 0 volts, and in the current through the circuit is 5 by R. Okay. So this is basically the analysis for up until T on, right? Now what happens when Vi is 0 volts? So when the like input is off, right, Vi equals to 0 volts, what happens then? Then like the circuit replaces like this. Inductor has whole charge of 5 by R flux energy, and this is R and this is VO. So what is VO? VO equals to minus 5 by R times R, which is minus 5 volts. Okay, VO is minus 5 volts. So if VO is minus 5 volts, so what will be like the IO? is also here like 5 by R, right? IO is 5 by R, but what is happening is slowly the IO will go to 0, right? Like this is the time when this is T on plus and this is T on plus, right? So both of these are T on plus, right? So if both of these are T on plus, then what will happen? Then what will be the steady state? This is a source free network, right? So at steady state the inductor will be short circuit, so voltage across resistor is 0, so VO is 0 basically. VO of T minus is 0 volts and IO of T minus is 0 amps. Okay, so like what is the current initially? What was it? It was like 0, then it went to 5 by R. Here it was 0 initially, then it went to 5 by R, then from 5 by R it went to 0, right? It went to 0 amps of current. So like initially it was 0, then it went to 5 by R very quickly, right? Because it has enough time. Then it stayed at 5 by R, then it again reduced to 0, and this cycle kept on going on. Okay, so this will keep on going on, right? So this is T on, this is T, right? And what is the voltage? So initially the voltage was like 5 volts, then it reached to 0 just before T on, again it went to minus 5 just after T on, then it went to 0 again. So the voltage waveform, right? Initially it was 5, then it reached to 0 volts, then again it went to minus 5, then it reached to 0 volts, then it went to 5, then it reached to 0 volts, then it went to minus 5 and to 0 volts, 5 minus 5. Okay, so it ripples around that. So also one more thing to note, how will you do this with intuition, right? So basic intuition is this is simple series RL circuit, right? So I'm talking about the first case, right, when T is less than L by R. So for the first case, what will happen? We know this is R and L. This inductor will reach steady state at some point of time. So when this reaches steady state, the average voltage across is 0. So VI average equals to IL average plus VL average, right? So VL average is 0, hence this is IL average only remains. So we can find out IL average, VI average by R. So that current flows through here. Then if VI average flows through here by R. So we can find the drop across this. From there we can find the output voltage, right? So that would be the intuition, what your mind should go in. Okay, also one more thing, you can see the method of compression works here. Basically, if we compress both of these waveforms, we get this and this, right? So here we are compressing this, so we are getting that waveform. So you can verify it for yourself. So this is basically a simple RL circuit. So let's go to the next question. Okay, so now solve this circuit. This circuit, right, the current IO average, right, will be same only, because just the L and R has been replaced here. If we see the circuit, I don't have the circuit previously. What circuit we have, just the R and L has been replaced, right? We have, this is the R in the previous circuit and this is the L, right? So it is in series only, so IO average will be same. What is IO average? Which is equals to VI average upon R, right? So it is 2.5 divided by R. So this is IO average. Now I will just start from here only. Okay, I will not do the initial analysis, because that's already done in the previous circuit, right? So in the case 1, right, when VI is 5 volts, let me draw the circuit. This is plus minus 5 volts. Inductor has some steady state current, and this is R, right? So this is the VO, and what is the IO? IO is basically 2.5, right, initially by R. And what is VO? VO is 2.5 by R times R equals to 2.5 volts. Okay, so VO is this, right? So what will happen to VO? So as here VL is positive, right? What is VL? VL is 2.5 volts, right? Because VI equals to VL plus VR, right? So it is 2.5, so VL is positive, hence IL will increase, right? so as a like charging is positive. Okay, so IL will increase. Now let's go to the second case, right, where Vi is 0 volts. Now when the Vi is 0 volts, what will happen? Basically this is 0, right? This has some current of 2.5 by R. 2.5 by R. This is simply a resistor R, and we have a output voltage VO. Right now we have output voltage VO. So what is the VO? VO is 2.5 only, right? And what is VL this time? VL is minus 2.5, right? Because like current is flowing in this direction and our VL is taken as this, right? VL polarity initially it was taken as this. So if VL is like minus 2.5, so IL will reduce. Okay, so as the rate of charging is like negative, so it will reduce. Okay, so I will tend to go to 0 volts. Sorry, I will tend to go to 0 amps, right? But obviously it won't go to 0 because like it will repel around that. So let me draw the circuit. Also one more thing is that basically if we know the I, right, we know the I from the previous circuit, right? I from the previous circuit. Now if we know the characteristics of I, right, we can easily find VO. What is VO? VO is equal to I times R. So basically if we know the I, then we know the VO also. So it's a very easy circuit to solve. So let me draw the like waveforms for in this case, right? So like IO will revolve around 2.5 by R and VO will also revolve around 2.5 volts. So initially what is happening, this VL is positive, right? VL is positive, hence IL will increase, hence IO will increase, hence VO will also increase. So both of them will initially increase here, then it will decrease. Why? We have like negative charging here, as IL will decrease, hence IO will decrease, hence VO will also decrease. So if VO decreases, it will reach to something like this point, right? Something like this, and this will also follow the same like waveform. Now let's go for the second case, right, when T is much greater than L by R, right? L by R. So if T is much greater than L by R, what will happen? Basically I will just draw the circuit. Okay, here this is plus minus 5 volts. This was the case A, right? This is like the inductor and this is the resistor. What will happen? Just I'm saying you, this 5 volt will totally charge this inductor, right? Initially it has 0 current, so this whole 5 volts, right, will come across this inductor because this has 0 drop, right, as 0 current is flowing. So this whole drop will come across this. So initially what is VO? VO initially VO 0 plus equals to 0 volts, as IO 0 plus equals to 0 amps, right? So both of these are 0. Now next what will happen, like just VO equals to T1 minus, right? What will happen? Basically we have plus minus 5 volts. This inductor is totally reached steady state and this has R, right? So what is the current through the circuit? The current through the circuit is basically IO T1 minus equals to 5 by R, right? So what is VO T1 minus? VO T1 minus will basically equals to 5 by R times R, which is equals to 5. Okay, so like as you can see also here it is short circuit, right? So it simply equals to 5. So next let's go for the like case when Vi is 0. So when Vi is 0, right, if Vi is 0, so we'll replace the inductor with a current source which is 5 by R and this is R. Okay, so if this is R, what will happen? Basically VO will be, again it will remain same, 5 by R times R, which is 5 volts. What is IO, right? IO is 5 by R only, right, like just at that instant. So like this is just at T1 plus. T1 plus, right? Now what is happening, like at steady state, this inductor will get short circuit and this is R, so there is no current through the circuit. So VO T minus is 0 volts and IO T minus is 0 amps. okay, is VRAM. So what will happen? Basically, if you draw the waveforms, right? So what is IO initially? IO initially is 0, right? Then it goes to 5 by R, then it goes to, again from 5 by R it goes to 0. So basically IO is IL only, right? So it will be similar like the previous question only. So it will go to 0 to 5 by R, then it will go to 0, then it will go 5 by R, then it will go 0, right? So 5 by R and 0. This is T on, this is T. Okay, same for VO, right? Same for VO. T on T. Okay, so like this will be the like waveforms for like the second case. Okay, now like if we see again the same condition, right? If we compress these waveforms, we will get that for that case when T is much less than L by R. So let's go to the next question. Okay, so let's start another circuit. So in this circuit we have been given two resistors, so we will assume for our ease of our calculation that R1 equals to R2 equals to R. Okay, now let's solve for the first case, right? The first case where T is much less than L by R1 plus R2. Okay, so like what will happen initially? We have this 5 volt source, right? We have this 5 volt source, and this is R1 and this is R2, and through here like this is open circuit, right? This is open circuit. So this is open circuit, through here 0 amps of current flows. If 0 amps of current flows through here, right? So what will happen? VL will be equals to VI only, which is equals to 5 volts, as drop across this, and this is 0 volts, right? So VL is positive, right? So IL will increase as VL is positive. Okay, so what will happen now? Basically slowly the inductor will get charged. It will try to reach IL steady state equals to like 5 by 2R, right? As when this becomes short circuit, so what current flows? 5 by 2R. But obviously it won't reach there, it will reach somewhat less value. So as the T is much less than L by R1 plus R2, so where it will reach? It will reach to somewhere around, let's assume that it reaches to IL of T on minus, right? IL of T on minus reaches to like 1 by R, assume that. Okay, so if it reaches to 1 by R, what is the voltage right now? This is 5 volts, this is R, and this current is 1 by R, right? And this is VO, this is VL. Okay, so like if this is 1 by R, so what is VO? VO equals to 5 minus 1 by R times R. Okay, as this is the current flowing, right? 1 by R current is flowing through this whole loop, so VO will be equals to 4 volts. Okay, and what is VL? We can write this, right? VO equals to I times R plus VL. So VL equals to VO. VO is basically 4 minus I times R. So I is 1 by R times R. So we have 3 volts, right? So VL is 3 volts. So it reduced, the charging rate got reduced. Initially it was 5 volts, now it got to 3 volts. Now what will happen is, for case 2, right? This is like case 1 when VI is like equals to 5 volts. Now for case 2 when VI is equals to 0 volts. Let me like solve it to the next page. Equals to 0 volts, right? So what will happen? This is short circuit, this is R, and inductor has some current of 1 by R, right? So this is R and this is R, this is VO and this is VL, right? So like through this whole loop the same current will flow. Okay, so like what is IL of T on plus? It is basically equals to like 1 by R only, right? Now what is VL of T on plus? VL of T on plus is basically equals to VO minus I times R, IL times R. What is VO? VO equals to minus of I times R, because this is the voltage across the resistor, right? It flows from like in the opposite direction. So what is I? I is minus 1 by R times R equals to minus 1 volts. So what is VL? VL is minus 1 minus of IL times R. So IL in this case is positive, obviously IL is positive. So 1 by R times R, which is minus 2 volts, right? This is VL of T on plus, right? So like we have covered the VL. So we can see it is minus 2 volts, so it is less than that initial charging rate, right? So here it was like 5 volts here initial charging, so it is less than that. So what will happen is now it will discharge to somewhat less value, like the difference between the discharge, right, will be somewhat less. Here what happened, initially the inductor from 0 it went to 1 by R, right? So here it won't totally like discharge 1 by R, it would discharge somewhat less. What is it? Basically now what is the current? The current is basically now what is the current? It is 1 by R, right? So it will let's assume it discharges to 0.5 by R. Okay, so it discharges to 0.5 by R. Now let's see for the like t equals to t plus, right? What happens? So for t equals to t plus, at t equals to t plus, right? So basically we have this circuit. This is again 5 volts, this is R, this is R, and this goes here, right? What is this current? This is 0.5 by R. So like what is VO? What is VO? So VO equals to 5 minus IR, right? So 5 minus like 0.5 by R, I is 0.5 by R. So this is 0.5, which is 4.5. So what is VL? VL is basically like VO minus I times R, right? So what is VO? 4.5 minus I times R, which is 0.5, which is 4 volts. So VL got reduced, right? It reduced to 4 volts. Here it was like 5 volts, now it got reduced, so the charging rate will get reduced. So now it won't go from 0.5 by R to 1.5 by R, right? It will go from 0.5 by R to 1.25 by R. So let's assume that IL of like t let's say it like t plus t on minus, right? It is equals to like 1.25 by R. Okay, so this is the IL. So now what will happen is that basically now let's draw the circuit. For that this will be short circuit. This is R, this is R, this is R, this is 1.25 by R, and this is VL, and this is VL. So at t equals to t plus, like this is t on plus, right? This is the circuit. So what is the VO right now? VO. So VO of t equals to basically I times R, which is minus 1.25 by R times R, which is minus 1.25 volts. What is VL? VL equals to VO minus I times R. So minus 1.25 minus I is 1.25 by R times R, so it is minus 2.5. So previously what was the VL? Previously the VL was minus 2, now it got increased to minus 2.5, right, in the negative direction, that is. So the discharging rate will increase here. So like again we do the same condition, right? When the charging rate is equal to discharging rate, then obviously the circuit reaches steady state. So here this is R, and we are assuming that the circuit has reached steady state. Then if the circuit has reached steady state, what will happen? Basically the average voltage across the inductor will be 0, right? So let me write the KVL. VI equals to ILR plus ILR plus VL, right? Now like both of them resistors are same. If I take the average in both the equations, right, what will happen? VI of average equals to 2 IL average times R plus 0, as VL average is 0 at steady state, right? So what is like IL average? IL average equals to 2.5 by 2R, it is 1.25 by R, right? So IL average is 1.25 by R. So like we've got the IL average. Now let's go for the case for like calculating the voltages, right, with the help of current. So when we are getting this IL average, when this dIL by dt, right, of discharging equals to dIL by dt of charging, both the magnitudes are same. Okay, so now let's draw the circuit. We have this resistor, we have this resistor, and this inductor has some current of 1.25 by R. This is R, this is R, this is V0, this is Vi, right, plus minus. So now what is the VO? VO is basically equals to let me draw the voltage here, it will be easier for you to understand, plus minus 5 volts, right, in case A, right, when Vi is 5 volts, Vi minus I times R, so it is 5 minus I. What is I? I is 1.25 by R times R, so it is equals to 5 minus 1.25, which is equals to 3.75 volts. Okay, so it is 3.75 volts, right? So we have got the output voltage. Now for the first case, now let's go for the second case, B, when Vi equals to 0 volts, right? So if Vi equals to 0 volts, let me draw the circuit. This is R, this is R, this is the current which is 1.25 by R, this is R. So one thing I forgot to mention here, what is the VL over here? If I draw calculate the VL, VL, right, what is VL? VL will be VO minus I times R, right? VO minus I times R. So what is VO? 3.75, right? So 3.75 minus I times R. I is 1.25 by R, so it is 1.25, which is 2.5. So as VL is positive, right, so IL will increase, so it will repel and it will increase slowly. Okay, now what will happen for the second case, right, when Vi is 0? So when Vi is 0, right, so some current will flow, right? We have to calculate the VO. So what is VO? VO is minus I times R, which is minus I is 1.25, so 1.25 by R times R, so it is minus 1.25, right? This is the VO. Now if this is the VO, what is the VL in this case? Obviously we understand this is a source free network, obviously it will discharge. Still let's check it. So VL equals to VO minus I times R. So I is in this direction only, I doesn't change its direction, right? So VO is minus 1.25 minus I times R 1.25, which is minus 2.5. So the VL voltage will repel around minus 2.5 to plus 2.5, and as this is negative, right, so IL will reduce, right? So here IL increases. Now if IL increases, right, if IL increases, so this VL will reduce, right, due to this equation. So as here also IL is reducing, right, VL will increase, but in the towards the positive direction. VL is already negative, so it will go towards the 0 volts, right? As here also we can see that this current is negative, right? So IL is reducing, so this negative value is reducing, hence VL will increase, but towards the negative the zero voltage. Here also we can see the inductor is trying to reach to the steady state, right? What is the steady state for inductor? Obviously the 0 voltage, right? That's what it's trying to reach. So that's why VL like always reduces here, tries to go towards 0. So let's plot the like waveforms. So like what will be the waveform? So initially like the current, right, what will happen to the current? Initially the current was 0, right, then it tried to charge, then again it discharged, let's say it charged to 1 by R, then it discharged to like minus 0.5 by R, then again it got charged to 1.25 by R, something like this, and it goes on like this. So at steady state, right, the charging and discharging will be same, charging and discharging will be same. So it will reach like its steady state voltage, which is which is actually 1.25 by R. So like this example is wrong, so I should like take this around, what should I take this? This should be 1.2 by R. So this is 1.25 by R. Okay, so this will reach 1.25 by R. So like this is the steady state for that. Now let's draw the output voltage. So what is happening to the output voltage? Output voltage, please do keep in mind, isn't 0, right? Average voltage isn't 0, average value of this. So initially the output voltage is plus 3.75 volts, then it goes to minus 1.25 volts, right, and it ripples around that. So what will be the output voltage? So the output voltage here we can see that initially it's 3.75, then it reaches to minus 1.25 and it ripples around that. So like what we can observe is that the output voltage is function of current, right? So the current increases, right, in the first case, right, as I mentioned, the current here increases, so VO will try to go towards 0, and here also the current reduces, right, IL reduces, so VO will try to go towards a 0 value. So if VO goes towards a 0 value, what will happen is like this is 3.75, then it goes to a 0 value, then this is minus 1.25, right, this is minus 1.25, so this is minus 1.25 and this is 3.75. okay, and it ripples around that. So like one thing you might say is that why isn't the average voltage 0? Why isn't it 0? Like figure it out, because here we are not taking it across the inductor, right, there is also resistor, and what is happening is if I write this, right, if I write this here, VO equals to IL times R plus VL. So if I write the average voltage, right, VO of average equals to IL of average times R, right. So like VL of average is 0, but there is some IL average, so there will be some average value of the output voltage, that's why. Okay, there is resistor and the current is constant. So what is the current? IL average is basically 1.25 by R, so VO average will be 1.25. So here you can check for yourself like your question is correct or not, I mean your solution is correct or not. Like if I check it, right, so 3.75 times T by 2 minus 1.25 times T by 2 divided by T. So what are we getting? We are basically getting like 2.5 by 2, which is 1.25, right. So we can check like our solution if it is correct or not. Okay, so like we got the VO average. Okay, so this is the VO average. So like I hope you know what is the VL average. So let's go for the second case, right. For the second case, when T time period is much greater than like L by 2R, what is happening? Basically we have R here, and this is L, and we have been given input of 5 volts, right, at T equals to 0 plus. So like what is the voltage across the inductor? Initially the current initially is 0, right, equals to IO. What is the voltage across the inductor? The voltage across the inductor is 5 minus I times R, which is basically I is like 2R, which is basically 0 I, so 5 volts only initially, right. So like at steady state, what will happen? This inductor will have enough time to reach its charge to its full current, right. So we have 5 volts, this is R, this is R, this is short, this R, this R, this I. So what is I? 5 by 2R, 2.5 by R. Okay, so inductor will get charged to this amount of current. Okay, so what is happening in the second case when the input is off, right? So when the input is off, the circuit is looking something like this. also in the previous case, right? Here VL is equals to 0, and what is VO? VO equals to like I times R plus VL, right? So here inductor is short, right? So VO is equals to 2.5 by R times R, which is equals to 2.5 volts, right? So this is the VL, this is R, this is R, and this is 2.5 by R, okay, and this is VO, right? So this is VO. What will happen? So basically slowly it will try to like discharge. This is a source free network, right? So initially what is VO? VO is minus I times R. Why? Because this is the plus minus of the resistance, like the polarity, and we are taking it from the negative terminal. So minus 2.5 by R times R equals to minus 2.5 volts, right? So like this is minus 2.5 volts. So VO suddenly goes from like a plus 2.5 to minus 2.5 volts. Then what happens? Basically then like this current goes to 0, right? So the circuit changes to something like this, source free network basically. So everything will discharge like at steady state. So VO of like T minus equals to like 0 volts, and IO of T minus also equals to 0 volts. Here like IO is the constant only, right? 2.5 by R. Slowly it will discharge. So let's draw the waveforms, right? So like what is IO? IO is going from 0, right? From 0 it is charging to 2.5 by R. Then from 2.5 by R it is going to 0. Okay, sorry, it should be amps here. Should be amps, and this is should be volts. Okay, so what is happening? This is going from like 0 to 2.5 by R pretty quickly. Okay, then again at T equals T1, this is going to 0, T1, and this is T, and this is like T plus T1. Okay, and this is T. Okay, and like this the circuit will like go on. What is happening to VO? So VO, like initially what is happening, VO initially is 5 volts, right, which is equals to VL only. So this is the VO, but after that what happens? It goes to 2.5, right? As the inductor voltage is 0, right, but this voltage across the resistance is not 0, so hence it will not go to 0, it will go to 2.5 as there is some steady state current. Okay, so it will go to 2.5, then suddenly the VO goes to minus 2.5 because there is some current here and drop is 2.5, minus 2.5. So it again it will like discharge to 0 volts, right? So if it discharges to 0 volts, what will happen? Basically this is 5 volts, right? So this goes to 5 volts, then it quickly discharges to 2.5 volts. Then again at T on, right, it goes to minus 2.5 volts, then it quickly discharges to 0, and this cycle keeps on repeating. Okay, okay, so this will how the waveforms will look like. Okay, like here also you can see, if we like compress this waveform, right, we'll get our previous results. Like if I compress this, like this will reach steady state and it will roam around that, and if I compress this, right, it has some positive and negative part, positive and negative part. So we'll like get an idea of how the waveform will look like. Okay, also like if you want to do this question with intuition, right, what you can do is like here in this initially this circuit, what is happening? Basically we are applying a voltage pulse through this inductor, right? So at steady state what will happen? This inductor, the average voltage will be 0, so the VL of average equals to 0, so whole drop will come across this. So VL of average, so VI of average equals to I times R1 plus R2, and I is the average current, right? So I average we will get as like VI average divided by R1 plus R2. So from there we get IL average, and if we get IL average, we know the average voltage across this, right? So we know the average voltage across this, and the average voltage across this is 0, so we can find the VO average, and from there we can find other conditions. We know the already the current, right? So from there we can find the voltage. So this is how the intuition should go like. So I did this like in longer manner, and like from analyzing point of view you can do it like that. Okay, so I think that's it for this question. Let's go to next question. Okay, so in this question, what is difference? Basically here we have like this inductor instead of the resistor. So for like again for ease of our calculation, we will put L2 equals to L1 equals to L, right? So L2 equals to L1 equals to L. Now let's like solve the circuit. So for the first case, right, when we're applying the input, Vi equals to 5 volt. So Vi is equals to 5 volts. And what is happening, L1 and L2 are in series and there are like zero current, there is zero current through this circuit. So R won't be present, as like at instant of t equals to 0 we have like infinite frequency content, hence like this L2 will dominate the resistor, right, in as it is in series. So this is L, this is L, and drop because the R is 0 as the current is flowing 0, right? So basically what will be the voltage, as both of them are L, right, it will be simply a voltage divider. So we can understand that 2VL equals to Vi. So VL equals to Vi by 2. Okay, so what is VL? VL equals to like Vi is 5, so it is 2.5 volts, right? So initially it is 2.5 volts, it is positive, as VL is positive, hence IL will increase. Slowly it will increase to like what point it wants to go. So at steady state, right, both of them will become short circuit. So like IL of steady state will be 5 by R only, right? Only the resistor will remain in the circuit. Like I will solve it in the like next case, you will understand, but for now you get this. Now let's solve like until what point it charged. So initially what is the IL initially is 0 amps, right? So what will happen is, so there is some finite voltage across the inductors, hence like it won't get like some current instantaneously. So what will happen, basically it will get charged to some value, right? Let's assume it gets charged to 1 by R of current. So IL of T1 minus, right, it gets charged to 1 by R of current. Now like what will happen is, if I draw the circuit for the B case, right, for the B case we have when Vi equals to 0 volts, so this voltage source won't be present. We have like inductor with 1 by R of current, and this is also a resistor and another inductor with 1 by R of current, right, and Vi is 0. So basically what is the VL this time around? This is R, right? So and this is VO, and this is basically the IO. Okay, so what is the VL? If I apply KVL, VL plus I times R plus VL equals to 0. So VL equals to minus I times R divided by 2. So it is basically I is 1 by R, so it is minus 1 by 2. So we are seeing that VL is coming something negative, right? So if VL is coming something negative, like it will discharge, right? So VL is negative, IL will reduce, right? So if IL reduces, what will happen? Basically it will try to go to 0 volts, right, but it won't go to 0 volts. So let's say it discharges, and one more thing, here VL is just minus 1 by half the discharging rate, and here the charging rate is like almost like 2.5, so it is much greater than that. So it will get discharged to from 1 by R, right, IL, it goes to, let's assume, goes to like 0.75 by R. Okay, so if it goes to 0.75 by R, now what will be the current in the next case, right? Like at t equals to t plus, right, what will happen at t plus? We have this voltage source 5 volt, we have this current which is 0.75 by R. Okay, and we have this resistor R, and we have this current source 0.75 by R. Okay, basically the inductor. So now what is the VL, right? Now what is the VL? So minus 5 plus VL plus I times R plus VL equals to 0, right? So 2VL equals to 5 minus I is 0.75 by R times R. So VL equals to basically 4.25 divided by 2. So it is basically 2.125 volts, right? 2.125 volts. So VL is like this value, this is positive, but one thing we observe is this is less than 2.5 volts, right? Previously we got 2.5 volts, so the charging rate will decrease again. So as it decreased, right, now it will go from 0.75 by R, this IL current, right, to, let's say it goes to like 1.6 by R. Okay, so if this goes to 1.6 by R, what will happen at t equals to t plus t on plus, right? So what will happen here, the input will be short this time, and this current is 1.6 by R, right? Here we have resistor, and this current is 1.6 by R, right? So if this current is 1.6 by R, so what is the voltage? Again, this is VL, this is VL. So 2VL equals to minus 1.6 by R times R. So VL is minus 0.8. So like VL, the discharging rate has increased, right? Here we can see it was minus 0.5, here it's minus 0.8, so it increased. So like slowly the charging rate is getting reduced and discharging rate is getting like increased, right? So at certain point, this VL of charging magnitude should be equals to VL of discharging. Okay, so if it goes equal, then we'll reach steady state, and at steady state the average voltage across the inductor is 0. So what will happen, let me draw the circuit. Here we have inductor, here we have inductor, here we have resistor, this L, this L, this is the VO, this is the VI, right? So if I like do the KVL, right, it is 2VL plus I times R. Now if I take the average, VI average equals to 2 times VL of average plus IL of average times R. So like what is IL of average, right? So IL of average is some constant value, but VL of average, right, this goes to 0 volts at steady state, right? So VI average is 2.5 and we have IL average, so I average times R. So I average equals to 2.5 divided by R. Okay, so this is basically the I average. Now like to what voltages will it ripple, let's see. So for case A, right, when VI equals to 5 volts, when VI equals to 5 volts, we have this circuit, this is plus minus 5 volts, this is some current, right? Inductors have some current, 2.5 by R, this is R, this is 2.5 by R. Okay, so what is the like output voltage, also what is the inductor voltage, right? So we like applying the KVL, 5 equals to VL plus I times R plus VL, right? So 5 equals to 2VL plus I times R. I, what is I? I is 2.5 by R times R. So what is VL in this case? It is 2.5 divided by 2, which is 1.25 volts. Okay, so VL is this amount of voltage, right? So again, what is happening, VL, as VL is positive, so VL is positive, so IL will increase, right? So IL will increase. So what is the VO? VO is I times R plus this VL, right? So IL is increasing, and like if you assume VL to be constant, then like VO will also increase, right? If IL is increasing, VO will also increase. So basically, what is the initial value of VO? VO is I into R, which is 2.5, right, plus VL is 1.25, so we get as 3.75 volts. Okay, so the output voltage initially is like 3.75 volts, right? So if it's initially 3.75 volts, let's check for the second case, right? For the second case, when VI is 0 volts, So let me draw the circuit. This has current of 2.5 by R, this is R, and this has current of 2.5 by R. Okay, and this is VO. So what is VO? VO is basically I times R plus VL, right? So let's first find the VL. This is VL, this is VL. So VL plus I times R equals to 0. So VL equals to minus I times R divided by 2, which is equals to 2.5 by R into 1 by 2, which is minus 1.25. Okay, so VL is minus 1.25 volts. Okay, so basically this is the VL. Now let's write the output voltage, which is equals to I into R. I into R is 2.5 by R, which is 2.5 plus minus 1.25, which is equals to 1.25, right, volts. But what is as VL is negative, so IL will reduce, right? So if IL reduces, then VO will increase, because this VO will also reduce because this is reducing, right? This I into R is reducing, hence VO will also reduce, so it will go to a 0 voltage in this case, right? In this case IL is increasing, right? So if IL is increasing, VO is I times R, so VO is increasing. So let us plot the waveforms. So here I have kept the 3 axes. So what is IO? So IO is always around 2.5 by R, right? Always around 2.5 by R. So from where it is moving, so here it is slowly getting increased, right? IL is slowly getting increased. So in the first half cycle it will slowly increase, then in the next half cycle, right, here IL is reducing, so it will slowly reduce and increase and reduce. Okay, so like this it will go on, ripple around 2.5 bar. Now here let's plot the VL. So what is happening to the VL? So initially the VL here is 1.25 volts, and here it is minus 1.25 volts, so it will ripple around 1.25 volts and minus 1.25 volts. So here it will go from 1.25 volts, then again in the negative half cycle from minus 1.25 volts it will go to a 0, then again in the positive half cycle from 1.25 volts, and like this it will go. Okay, so this is reducing. The VL will always try to go towards 0, right, at steady state. So what is the output voltage? So the output voltage, right, here if we see, initially the output voltage is 3.75, right, and it is increasing, then it is 1.25 and it is decreasing. So it is 3.75, increases, then it goes to 1.25, then decreases, and this cycle continues, right? This cycle continues. Obviously I am exaggerating this, but the difference won't be that much. It will be around 3.75 only, right? So this is 3.75 and this is 1.25. Now here if you want to cross check, right, if your waveform is correct, right, what you can do is what is VO? VO is I times R plus VL, right? What is VO average? VO average is I average times R plus VL average, which is 0. Okay, so we know I average, right? It is basically 2.5 by R, so 2.5 volts our VO average should come, right? So is it coming? Yes, it is coming. If you do the calculation here, it will be 2.5 volts. Okay, so this is basically for this case. Now let's go for the next case, right? What will happen in the next case? So basically in this case, right, when T is much greater than L1 plus L2 divided by R, right? So in this case the inductors will have enough time to reach steady state. So what will happen? Let me draw the circuit. So in the case A, right, in the case A we have this plus minus 5 volts over here. This is inductor, this is inductor, and this is resistor. This is L, this is L. So initially what is happening? Initially there is 0 current, right? So IL let me write this as like Vi equals to 5 volts. So initially IL equals to 0 amps, right? Now where it is reaching to steady state when both of the inductors are short circuited. So if both of them are short circuited, what will happen? It will reach to 5 by R, right, at steady state. And what is happening to VL? So if I apply the KVL to VL, like 5 equals to 2 VL plus I times R. So VL of 0 plus, right, it is basically like 5 by 2, which is 2.5, and VL of T on minus, right, it will reach steady state, hence the voltages across the inductor will be 0, right? So it will be 0 volts. Like let me write this in a better manner. So this is basically IL of 0 plus, and this is basically IL of T on minus, which is 5 by R of current. Okay, so we have got the VL of T on minus. So what is VO of T on minus, right? So VO of T on minus is basically equals to like this VL plus I into R, right? So what is VL? It's 0 volts plus I. What is I? 5 by R times R. So it is basically 5 volts, right? So VO of T on minus is 5 volts. Now let's see what happens in the second case, right, when Vi equals to 0 volts. So when Vi equals to 0 volts, what will happen? This inductor has some current of 5 by R. This is the resistor, right? And this inductor also has some current of 5 by R. Okay, so what is the output voltage? So the output voltage basically will be this minus VL, right? This is VL, this is VL, minus VL. So what is VL? 2 VL plus I into R equals to 0. I naught of T on plus equals to 5 by R only, as inductors won't change their current instantaneously. So what is VL? VL equals to minus 2.5, right? Basically 5 by 2 is VL, so it is minus. So here VL is coming negative, so what will happen? IL will reduce. So if IL reduces, right, if IL reduces, like then like this VL will also reduce, as it is dependent on current. So this will discharge slowly. So what is VO? VO is again minus of VL, so which is equals to plus 2.5 volts, right? It is plus 2.5 volts. So here like VO will also reduce. So at steady state, what will happen? Obviously this is a source free network, so both of the inductors will de-energize and we will be left with nothing, right? Only 0 have some current flowing and the voltage is 0, right? 0 volts. So what is like this time instant, right? This time instant is T on plus. Now VO of T minus, right, it is basically 0 volts. IO of T minus is basically 0 volts. Now let's draw the waveforms. So for the current waveforms, right, initially what is the current? Current is 0 amps, right? Then it is going to 5 by R. Then what is happening? Then basically from 5 by R, right, here the current is 5 by R, it's going to 0. So sorry, this will be amps. Okay, so it's going to 5 by R very quickly, right? Very quickly. Then it's going to 0. Then it's going to 5 by R. Then it's going to 0. Okay, so this is 5 by R. Okay, so now let's find the VO, right, output voltage. So for the output voltage, what will happen? Basically initially what is the output voltage? It is 2.5, right? So as the drop across here is 0, so output voltage is 2.5 across this inductor only. So then the output voltage is going to 5 volts, as the inductor is going to 0 volts, but there is some finite current flowing through the resistor, that is 5 by R. So 5 by R into R is 5 volts, right? So from 2.5 it's going to 5 volts exponentially very quickly. Then what is happening in the like other half, right, it's going to plus 2.5 volts. So from plus 2.5 volts it's going to 0 volts. So it suddenly went to 2.5 volts, then it charged to 5 volts, right, pretty quickly. Then again like it went to plus 2.5 volts suddenly, then it discharged, right, pretty quickly. So like this will be the waveform. It is plus 2.5 volts, then it charged very quickly, then again it discharged sorry, then again it come back to 2.5 suddenly, and then again it discharge, right? Okay, so this cycle will keep on going on. Charge, come back, then again discharge, right? So this is the 2.5 volts and 5 volts. So like can we observe the circuit? Like if we obviously compress both of these waveform, like we can see that we are getting something like plots like this only, right? It's charging, then discharging, it's charging, then suddenly reducing, then discharging. So here we can relate that it's charging, then suddenly decreasing, then discharging. Okay, so this is basically the like the analogy like you can find. Then we have finished this question. We'll go to next question. So this is the next question. Like we have like similar question like the previous one only, right? So this is inductor, this is resistor, and we are taking the output voltage across this. What is added from the previous question? Only an extra resistor, right? So if I like see the previous waveforms, can this like be same in the this question also? I think it will be same, right? Why? We are only adding one resistor, right? So what happens with resistor? Basically there will be one extra drop across this resistor, hence this output voltage, average output voltage will reduce, right? Also the average like current will also reduce. Why? Because what is the average current? Basically like this VI average upon R1 plus R2, so that will also reduce. Okay, so like these two things will occur. You should like keep in mind how to like keep like analogy from the previous questions and like use those concepts here. Okay, so now let's first solve this question. So let's assume that R1 equals to R2 equals to R, right? So if R1 equals to R2 equals to R, what will happen? Basically let's first write when Vi equals to 5 volts, right? So if Vi equals to 5 volts, initially like there has been zero current across the inductors, so the inductors will become open circuit and they will dominate against the resistors, right? So only inductors will remain. Also L1 should be equals to L2, which should be equals to L. Okay, so only inductors will remain. So this is L, this is L, and this is VO. So initially VO, what will be it? It will basically be voltage division 5 by 2, which is equals to 2.5 volts, right? So as VO is 2.5 volts, right? So VL is positive, hence IL will increase, hence IO will also increase, right? What is IO initially? IO is 0 amps. So IO will also increase. So to what steady state value they will want to increase, right? They will want to increase. If I like draw the equivalent circuit, like if the inductors reach steady state, right? This will be R, and this is 5 volts. Okay, and this is VO, right? So what is VO of steady state? It is basically 2.5 volts. And what is IO of steady state? It is basically 5 by 2R, which is equals to 2.5 by R. Okay, so it will want to reach to 2.5 by R. Obviously it won't reach there. Okay, as like we don't have the time period of the waveform, input is much less. So what will be the like output voltage and the inductor voltage when we reach like some current of IO equals to 0.5 by R, right? So if IO has reached to 0.5 by R, so this is 5 volts and inductors are charged to 0.5 by R, right? This is 0.5 by R. This is a resistor. This is 0.5 by R. This is resistor, and this is R, this is R, and this is VO, right? So this is VO. So like let's calculate the VL. So one thing to notice is that VL1 will be equals to VL2. Why? Because VL1 equals to L di by dt, and VL2 is also equals to L di by dt, right? So both of them will be equal. But what will be it equals to? Basically simply applying the KVL across this loop, right? If I apply KVL, what we'll see is that 5 equals to 2VL plus I times R, right? So what is I is 0.5, so it is 1 by 2 times 2 R, so 1 goes there, so VL equals to 2 volts, right? So VL is 2 volts, so it's positive. Now what will happen, like what is VO right now? VO is basically this VL plus I into R, VL plus I times R. So VL is 2, I times R is 0.5 by R times R, which is 2.5 volts, right? So what will be like the next state, right? When Vi equals to 0 volts. So Vi equals to 0 volts, this is gone, inductors are replaced with current source, right? They won't change its current suddenly. So this is 0.5 by R, and this is R, and this is R, and this is VO, right? So if this is VO, so like let's calculate what is VL right now. So again the inductor voltages will be same, VL. So 2VL equals to like 2VL plus minus 2VL plus I times 2R, right? They are in series, equals to 0. So VL equals to minus 2IR divided by 2, which is I into R, which is minus 0.5 volts. So as you can see, like inductor voltage is negative, so it will discharge slowly. Okay, so if it discharges, like what is VO right now? VO is VL plus I times R. It is basically equals to minus 0.5 plus I is 0.5 by R times R, which is equals to 0 volts, right? So VO in this case is 0. Now slowly the current will decay. It will try to reach obviously 0 volts, but it will like it's 0 amps. It will not reach there as the time period is less. So next what happens? Next C case, again when Vi is 5 volts, right? So let's draw the circuit. So Vi is 5 volts, and let's say like in the previous case, right, what happened? It discharged. So let's say that the current was 0.5 by R. So discharge, so let's say IO discharge to 0.25 by R. Okay, so discharge to 0.25 by R. So what is the VL in this case? VL equals to again this minus I times R, so it is 0.25 volts. Okay, and what is the VO? VO will be 0, so it will like remain on 0. Okay, so this is the case. So let's draw our circuit. Here we have one current source, 0.25 by R. This is resistor, this is current source, and this is VO, right? So like what is the VL right now? So again if I apply KVL, 2 VL plus 2 I times R, so VL equals to 2.5 minus I times R, so 2.5 minus I is 0.25 by R, so it is 2.25. So now VL has reduced, right? It reduced from 2.5 volts. Okay, so VL reduced from 2.5 volts, right? So you can see initially what was VL? Initially VL was 2.5 volts. That is basically the output voltage. Now it got reduced, so the charging rate is decreasing, and like again the discharging rate will increase, right? So what will happen? Let's say as it reduced to like 2.25 volts, so it won't get charged to like 0.5 by R. Now in what it will get charged? Let's say it got charged to 0.6 by R, right? So this is positive, so again IL will increase. Let's say IO gets charged to some value 0.6 by R. So what is the VL in this case? So VL will be basically 2.5 minus I times R, right? So as it charged to 0.6, so it will be 1.9 volts. Okay, so VL is this case. Now let's go to the case D, again when Vi equals to 0 volts. So if Vi equals to 0 volts, right? If Vi equals to 0 volts, what will happen? Let me draw the circuit. This is inductor and this is the current source. It charged to 0.6 by R. This is the resistor, this is the inductor 0.6 by R, this is the resistor, and this is short circuited, right? So like what is the voltage? Again the voltages will be same, right? VL, this is I. So like what is the voltage? VL equals to minus I times R, So it is basically 0.65, so it is minus 0.6 volts. Okay, minus 0.6. So as you can see that it increased, right? Our VL has increased. Previously it was 0.5. If you can see here, it was 0.5. So obviously discharging rate is increasing, and charging rate is reducing. So at some point of time they will equate. When will they equate? Like when the average voltage across the inductor is 0. So let's equate for the case when charging rate equals to discharging rate. Okay, so if a charging rate equals to discharging rate, what will happen is basically we'll have like this type of circuit. This is like VI only, right? And this is inductor, resistor, inductor and resistor, right? This is R, this is L, R, L, this is VO, and from here we're giving the VI, right? So what is VI? VI equals to 2VL plus 2VR, right? Now like the average voltage across the inductor is 0, so VI average equals to 2 times 0 plus 2 times I average times R. So basically what will be the current? I average equals to VI average. VI average is 2.5 divided by this 2, right? So I average is 1.25. like if you notice in the previous like question, you will see that there I average was only like 2.5 only. It divided by 2. Why? Because there is extra resistor, right? So that's why it got divided by 2. We got the I average. Now let's find the like voltage conditions, like for T on, before T on and after T on. So we have got the I average. So let me replace for case A, right? When VI equals to 5 volts. So when VI equals to 5 volts, this is plus minus 5 volts. Here we have inductor of 1.25. sorry, this will be 1.25. sorry, this will be R, right? This will be R. Okay, so this is R times R divided by 1.25 by R, and there is a resistor. Okay, so there is a resistor basically. So like what will happen is that what will be the VO right now? Let's first calculate the VL. So basically 5 equals to 2VL plus I times R2. So VL equals to 2.5 minus I times R, 1.25, which is equals to 1.25 volts, right? So VL is basically equals to 1.25 volts, right? So what is VO? VO is VL plus I times R, which is 1.25 volts plus I times R, which is 2.5 volts. VL is basically like 2.5 volts, right? So why VO is 2.5 volts? Basically what we can see is it got shifted by 1.25 volts, right? Due to this resistor, right? Due to this resistor, it got shifted by like 1.25 volts. Now let's see here, as VL is positive, right? As VL is positive, so like I will increase, and what is the like formula for this VO? As I is increasing, hence VO will increase, right? Yes, VL will also reduce, that is correct, but like we will like assume that like I is increasing more, right? So as I increasing, so VO will increase. Okay, so now let's go for the next condition. When VI is 0 volts, so when VI is 0 volts, right, we have this current source of 1.25 by R, this resistor, this current source of 1.25 by R, this resistor. So what is VO, right? So here what we see, again applying the KVL, 2VL equals to minus 2I times R. So VL equals to minus I times R, so which is equals to like minus 1.25 volts. So VL will repel around like 1.25 volts, right? VL will repel around like plus 1.25 and minus 1.25, but VO will get shifted by 1.25. Why? Because there is some constant current flowing through this 1.25 by R, and there is some drop 1.25 by R into R, so it will get shifted to the to the positive half, right? So that's why, like, what will be VO right now? VO is VL plus I times R. Again, like VL is minus 1.25 plus 1.25, it is 0. So it is just getting shifted, right, due to this I into R term. So now what we see is, as VL is negative, so the current I will reduce. Anyway, this is source free network, so obviously current will reduce. So what will happen? This I will reduce, hence VO will reduce. Okay, so like VO will reduce slowly. Okay, also like VL will also reduce here, right? So VO will reduce here anyways. So let's draw the output waveforms right now, how the output voltage waveforms will look like. So first let us draw the current waveform. So here we know that the current waveform will repel around 1.25 by R. So this is 1.25 by R. This will repel around this, right? Okay, so it will get repel around this. Why is this increasing initially? This is T on and this is T. Okay, now let's plot the voltage across the inductor, right? So what is happening across the inductor? So initially, like when we calculated, so initially in this case, right, VL initially was this 2.5 volts, right? 2.5 volts. Now suddenly what happened? It was reducing. It reduced to like this 2 volts in the T on, before T on, right? Then what happened? Suddenly it changed to what value? To negative 0.5 volts, right? Then what happened? Then again it's reducing towards, going towards 0, because it wants to go to the steady state, right? That's why. So this is negative 0.25 volts. Now again what is happening? Again at T equals to capital T, it got to 2.25 volts. It was previously 2.5, now it got to 2.25 volts. Again it starts reducing. As it starts reducing, what is happening? Like in the next cycle it got to minus 0.6 volts, right? So like if I draw this not in steady state initially, so suddenly it went to 2.5 volts, then it started reducing, then it went to somewhat less value, then it started reducing, then again it went to somewhat less value, then it started reducing. Here it increased, right? The discharging somewhat increased, then it's reducing again here. And what is happening? Basically a steady state, right? The average voltage will be 0, and within like which points it will repel. Let me draw those points. Those points will be here only, that is like minus 1.25 volts and this plus 1.25 volts. So it will repel around these two only, 1.25 volts and minus 1.25 volts, right? So like this will be the voltage across the inductor. So what will be the VO, right? VO will be shifted times R and add this only. Okay, so what will the VO look like? So VO will look something like this. So like as we can see, right, in this waveform, I is increasing and VL is reducing. So we can exactly say how it will happen. We can say like it's some constant value or something. We can say that. So this will be 2.5 around like this. Then suddenly it goes to like 0. Then what happens? This I reduces, right? This I reduces, and this also reduces. So both of them reduce. But one thing to notice is that this VL is actually like decreasing. This VL is actually decreasing, but like obviously in the positive direction it is decreasing, right? So in actual sense this VL is increasing towards, going towards 0, right? And here it is decreasing. Here also we can't totally say like what will happen to the output voltage, but we can say like it will repel. We can draw it like this, that we can assume that the increase in VL is more. Okay, so if increasing VL is more, we can assume it's going like this, then this is this and this. Okay, so it will repel around that only. So from here we can see what is the average output voltage. So VO average equals to 2.5 divided by 2, which is 1.25, which is exactly what we expect, because VO equals to VL plus IO times R. So VO average equals to IO average times R. Okay, so this will be like the solution for this case. Now let's go for the next case. So next case is like when T is much greater than L1 plus L2. So when T is much greater than L1 plus L2, so let's first draw when Vi equals to 5 volts, right? So if Vi equals to 5 volts, what will happen? This is plus minus 5 volts, and like initially what is happening, that inductor is like open circuit, right? The same condition. This is a resistor, this is a resistor, R. So what will be the voltage? This is VL, this is VL. So what will be the voltage across this? So 2VL equals to 5. So VL equals to 2.5 volts, right? So VL equals to 2.5 volts. So like we have got the VL. So what will happen? Slowly it will charge, it will reach steady state, right? So at steady state, what will happen? This is at T equals to 0. So at steady state, basically they will get shorted. This is R, this is R, this is plus minus 5 volts, this is R. So what is the current? Current is basically, let me write this, current is basically 5 by 2R, which is 2.5 by R, right? So it reaches steady state, and like the steady state current is 2.5 by R. So like how will it look like? So initially what was IL initially, this was at 0, and IL initially was 0 amps. What is VL right now? Obviously VL is 0. Okay, what is VO right now? VO is this I times R plus VL, which is equals to 2.5 volts only. Simple voltage division, right? So like here, what is VO? VO is 2.5 volts. Okay, 2.5 volts. Let me write this at T equals to 0, and for this circuit, right, this is at T equals to T on minus, at T equals to T on minus. Okay, so this is basically the case. Now like let's solve for when the Vi is like off. So if when Vi is off, right, 0 volts, so what will happen? Inductors are charged to like what was this, 2.5 by R, right? So inductors were charged to 2.5 by R. This is resistor, 2.5 by R, and this is resistor. Okay, so what is IO just at T equals to T on plus? It is only let me draw this circuit at T equals to T on plus, right? And this is at T equals to T on plus. So what is the like current? Basically the same, right? It won't change suddenly. What is the VO? VO will be, let's first calculate the VL, right? So what is VL? This is plus minus VL, this is plus minus VL, both of them will be same again. So 2VL plus 2 times I into R equals to 0. So what is basically the VL? VL is basically this I times R, negative sign. So this is minus 2.5 volts. Okay, so VL suddenly goes from plus 2.5 to minus 2.5. Okay, and what is VO right now? VO is like this is plus 2.5 and that is minus 2.5, right? Plus I times R, which is minus 2.5 plus 2.5, which is 0 volts. Now what is at T equals to like T minus, right? T equals to T minus. What is happening? Everything is off, right? Everything is off. Source free network basically is, it will discharge. This is R, this is R, and this is off, and this is VO. So VO is 0, IO is 0, everything is 0, VL is 0. Okay, so let's now plot the waveforms. So what is happening to IL? Initially IL was 0, right? Initially IL was 0, then it went to 2.5 by R, then from 2.5 by R it went to 0 again, right? It went to 0 again. So let me like draw the waveforms. It was 0, then going to 2.5 by r, like pretty quickly stayed there, then we went to 0 again pretty quickly, 2.5 by r, then went to 0. Okay, 5 by r, right? Now like what is VL? VL is like swinging between 2.5 and minus 2.5. so here initially VL was 2.5, then it goes to like 0, right? Then it goes to 0, then again it goes to minus 2.5, then again it goes to 0. So initially VL was 2.5, then it went to 0, it reaches steady state, then again minus 2.5 went to 0, then like this only. Okay, so like this 2.5 and minus 2.5. okay, so what is VO right now? So VO is basically the shifted part, right? 2.5 by r will be added. So basically what will happen is there will be very slight ripples, then it will suddenly reach 2.5. okay, suddenly reach 2.5, then again suddenly it will go to like 0, like this, and this will be the waveform, right? Slowly again goes to 2.5, and then again it really like suddenly jumps down to this 0, right? So this will be the basically the waveform of VO, right? So this will be the waveform of VO. So we have solved this question. Now let's go for the next question. Okay, so let's now solve for the next circuit. Like this has been the same circuit as in the like bridge circuit as the RC one, right? So like let me convert this circuit like this. This is R, L, L and R, right? And like we're naming this as 2 and 4, this is 1 and 3, right? So what is the VO? VO equals to V2 minus V4. So it will be like the same case only. I will just analyze it a bit fast. Okay, so what is happening basically for the first case, right? When T is much less than L by R, what is happening? This inductor, right? This inductor will have some average current. What will be the average current? So I2 average equals to, this is VI, right? So equals to VI by R, which is equals to like VI average by R, which will be equals to 2.5 divided by R. okay, so what is like the VL in case? Let's first calculate the I4 average, right? So what is I4 average? I4 average is also same 2.5 by R. okay, so let's first calculate the V2 and V4 for like the initial conditions and like for T on and after that. okay, so for the first case when Vi equals to 5 volts, so the like circuit will get replaced like this. This is 5, like this is the resistor and inductor X being replaced with 2.5 by R and R, and this is 2.5 by R, and this is R, right? And this is this is V2 and this is V4, right? This is the fourth terminal, right? So like what will be the voltage right now? What is V2 of like initially, what is V2 right now? V2 is equals to simply 5 minus I times R, so 5 minus 2.5, which is 2.5 volts, right? What is V4 right now? V4 is simply I times R, right? I times R, which is 2.5 only. So what is VO right now? So VO is 0, right? VO is basically V2 minus V4, which is 0 volts. So like one thing to observe is like this V2, right? This V2 is only VL, right? So this V2 is VL. As VL is positive, IL will increase. it will charge, right? As this is higher potential, it will charge. So IL is increasing, so this VL will reduce, right? This drop is increasing, this VL will reduce, so like this V2 will reduce. Okay, so what is happening in this case? Here also I is increasing, right? I is increasing, I is increasing. As if I is increasing, so what will happen? This V4 will increase, right? So V4 is increasing and V2 is reducing, right? So what is happening? This is increasing, this is reducing, and this is increasing, right? So V0 will also reduce. Okay, so in the first case V0 will slowly reduce. Now what is happening in the case B, right? Case B when Vi equals to 0 volts. So if Vi equals to 0 volts, right? This is like in this is resistor, right? This is the source, 2.5 by R, and like this is 2.5 by R. Okay, R, this is 2, this is 4, right? And like this is VO and this is IO. So I forgot to calculate the IO, right? Here IO. What is IO? So IO is basically 2.5 by R plus 2.5 by R, right? So IO equals to 2.5 by R plus 2.5 by R, which is 5 by R. What is happening to the IO? IO will basically try to increase, right? So IO will try to increase. It will try to increase. Why? Because both of these currents, because IL is increasing, right? So IO will slowly increase. Okay, so now let's calculate for the like this next case, right? Here what is IO again? IO is again like 2.5 by R plus 2.5 by R, right? Now what is like V2 right now? Like if I apply KVL across this loop, applying KVL across this loop, so V2 equals to basically this is plus minus V2, right? And applying KVL, V2 plus I into R equals to 0. So V2 equals to minus I into R, which is minus 2.5. So V2 suddenly goes to minus 2.5 volts. And what is like V4? So V4 is only 2.5 only, right? V4 is basically I into R, which is 2.5 volts, right? So like what is VO right now? VO is minus 2.5 minus 2.5, which is minus 5 volts, right? So VO is minus 5 volts. So like now what we observe is this voltage, right, is negative, so it is reducing. VL is negative, so VL is negative, so IL is reducing. So what will happen? Like this is reducing, right? So like V2 is reducing. What is happening to V4? V4 is also reducing. So V4 is also reducing, right? V4 is also reducing. IL is reducing, hence V4 reduces. So what will happen to V0? So both of them are reducing and both of them are going towards like zero voltage, right? So if both of them are going towards 0 voltage, V0 will also reduce, as at steady state everything will become 0, right? So they will try to go towards the 0 voltage. Okay, and what is the I0? So I0 basically, I0 will also reduce, right? From like 5 by R, I0 will reduce. So here it is 5 by R, right? So from 5 by R it will try to go to 0, right? But it won't. Obviously the average voltage will be 5 by R only. It will repel around that. Okay, so let's like draw the waveform. So what is IO? IO is around 5 by R only, right? IO is around 5 by R only, 5 by R only. And from where it is shifting, basically like initially what was happening, IO was increasing, right? IO was increasing, this was increasing. Okay, so and then what was happening, IO was reducing. So initially what will happen, it will repel around 5 by R and it will increase and decrease, increase and decrease. Okay, so this will keep on happening. Now what is VO? So VO initially what was it? Initially VO was like this 0 volts, right? And it was reducing. Okay, then what happened? Then VO was minus 5, then it was also reducing towards 0 volts, right, towards 0 volts. So like initially it was 0 volts, then it was reducing here, like let me draw this correctly, then suddenly it went to like minus 5 volts, then also it started reducing again, went to 0, reducing, minus 5, reduced, and like this it will go, like go on, right. So this is like minus 5 and this is 0 volts, right. So like what is the average voltage, VO of average? So VO of average, right, equals to minus 2.5, right. Here like can we cross verify this? So VO equals to basically V2 minus like V4, right. And what is V2? V2 is basically voltage across the inductor, so it is VL minus, and what is V4? V4 is basically the voltage across the resistor, and this is inductor, so this is I times R, this is VO. So VO average, if we calculate, right, here it is coming to be 0 minus I average times R. Let me go to the next page, like if I write this in a better manner, take this here. So what is I average? I average is basically 2.5 by R times R, right, and this is VO average, it is minus 2.5 VO average. So you can like check it, like cross verify it, like whether you are correct or not. Okay, so it's coming, so the our like solution is correct. So let's go to the next question. Also one thing is that like you can't assume that VO average is 0, that like this is inductor voltage and it is 0. No, like this is not inductor voltage because there is a resistor here, right. So we are not taking the voltage across the inductor. So let's go for the next case, that is like for T like much greater than L by R. Okay, so let me draw the circuit first. This is the resistor and this is the inductor, right. So initially what will happen? Initially the inductor will be 0 amps of current, right, across it. So this is like we are applying VI. Okay, so what will happen, like at T equals to 0 plus, the circuit will look like this. This is open, this is R. Okay, this is VL and this is VL. Okay, so like what is this V2 and V4? So V2 will be 5 volts only, right, because the drop across it is 0 amps. So V2 is 5 volts. What is V4? V4 is 0 times R, which is 0 volts. So what is VO of 0 plus? It is 5 volts, right, it is 5 volts. Now like just before like T on, right, just before T on, the circuit will look something like this. This is plus minus 5 volts and this is the resistor, this is shorted, this is shorted, this is plus minus 5 volts, right. This is 2, this is 4, this is R, this is R. Okay, so what is like the voltage? V2 is like 0, and what is V4? V4 is I times R, which is basically 5 volts, right. The whole voltage is coming at this point, right. So it is 5 volts. For in this case also I forgot to write the IO, right. What is IO? IO is basically here 0 amps, because this is 0, this is 0 amps. IO is 0 amps. What is IO here? Like IO here is 5 by R plus 5 by R, which is 10 by R. So current here is flowing 5 by R, here also 5 by R. So IO is 10 by R. This circuit is T equals to T1 minus, right. This is T equals to 0 plus. Okay, so like this is the circuit. So like now let's draw for the next case, that is basically T equals to T on plus, right. So at T equals to T1 plus, what will happen? Like this is shorted, right. and this is the resistor, and this is the current source, which is 2.5 by R. Sorry, this is not 2.5 by R, this is 5 by R, right? 5 by R. So like what is the like voltage? This 2 and 4, right? This 2 and 4, and this is R. Slowly it will reduce, right? But obviously it won't get reduced to like 0 volts very fast, because but obviously it will get reduced to like 0, right? Steady state everything will become 0. This is at t equals to t on plus. What will happen? What is the V2 right now? V2 is basically equals to minus I times R. I hope you can apply the KVL, which is equals to minus 5 volts, right? What is V4? V4 is again 5. So what is VO? VO is like minus 5 minus 5 minus 10 volts. Okay, what is IO? IO is basically the summation of these two, right? So IO equals to 5 by R plus 5 by R, which is 10 by R. So as we can see, this like V2 is coming negative across the inductor voltage, so it will discharge, right? So at steady state, what will happen? Steady state, this is R, this is short circuited, this is short circuited, these are like this is a source free network. Basically like this is a source free network. Basically this is at t equals to t minus, so everything will be 0. So like if I write this, right, at t equals to t minus, everything is 0, right? Like IO is 0, VO is 0, like V2 is 0, V4 is 0. Okay, everything is 0. So let's like draw the waveforms now. So like what is the current? Current is from start, right? From start, current initially is 0, then it went to 10 by R, then it again from 10 by R, right, it went to 0. So it will be same only, right? It will from 0 it will go to 10 by R pretty quick, then from 10 by R it will go to 0, then from 0 to 10 by R it will go pretty quick, then it will go to 0, right? Okay, so this will be the current plot. So now let's plot the VO waveform, right? So what is happening to the VO? So initially what was VO? VO was initially 5 volts, right? And in this case, right, sorry, I forgot to write, VO is here minus 5 volts. Okay, so then it went to minus 5, like from 5 to minus 5 it went exponentially, then suddenly like it will settle there, it will stay there for a while, then just after that, right, what will happen is that it will go minus 10 volts, right? Suddenly it will jump to minus 10 volts, then exponentially it will go to 0 volts. So how the waveform will look like? Let me draw it here. Like from plus 5 it is going to minus 5 pretty quickly, right? Plus 5 minus 5, it is going pretty quickly, then it remains there, then suddenly it jumps to minus 10, then again it decays exponentially and it stays there. So this is plus 5, this is minus 5, it remains there, right, until t on. This is t on, right? Write this t on, right? And it goes to 0, and this is t, then suddenly it goes to plus 5, this is, then again it decays pretty fast, then it remains there, then it goes here to minus 10, and then again it goes there, right? So this is how the cycle will look like. Again it will go, again it will decay like this only, right, here, then here. Okay, so this will how the like waveforms will look like. Okay, so this is it for this question. Okay, like one more thing is that here if you see, right, if we compress this, are we getting like our waveforms like in the previous case? Yes, this is like charging and discharging. Here what is happening, basically it's not showing this, right? It's like 5 volts for very less amount of time, so bit positive, then decreases, then suddenly goes to negative, and then increases, right? So what is happening here? Here also bit positive, then decreases, and suddenly goes to negative, then also increases, I mean then goes to 0, this also goes to 0. So you can like cross verify this waveform, right? So yeah, I think that's it for this question. Let's go to like next question. In next question we'll solve for like current source input, right? Okay, Okay, so in these questions, right, there will be a bit of change. So we have changed the source right now. The source is a current source which is a square pulse and which has like 5 volts of peak amplitude and sorry, not 5 amps of peak amplitude and 0 amps like during off, right? So now the source has changed. We will plot for both of these cases when time period is much less than time constant and time period is much greater than time constant. Okay, so let's first go to the first circuit. So this is basically simply a parallel RC circuit. Okay, so what we can do is here, like I will solve this in like short manner and next questions I will solve in rigorous manner. Okay, so what we can do here is we can apply source transformation, right? So if we apply source transformation, basically this current source, right, can be replaced with a equivalent voltage source whose voltage will be equals to its equivalent current and its equivalent resistance, right? So basically if we replace this with a voltage source, this is plus minus I times R and this is equivalent resistance and this is its capacitance, right? So basically now it's rather simple. We have already solved this for in our previous questions, right, with a voltage source, resistor and capacitor. So like what will be this like, so here what is I into R? I into R is basically 5 times R, right? 5R. Okay, so what will be this? So we'll directly solve this. What will happen? This voltage source is what? VI, right? VI equals to II times R should be equals to IC times R or IO times R plus VC, right? Now what is happening at steady state? At steady state the average current through the capacitor should be 0, right? So if I take the average, right, IIR average should be equals to IO average times R plus VC average. So like what is IO average? IO average equals to 0 at steady state. Why? We have already like solved this rigorously in the previous examples. So it's 0. So like now what is II average? II average is basically 2.5 amps, right? Basically half of that. So this 2.5 times R equals to 0 times R here plus VC average. So what is VC average? VC average comes out to be 2.5 times R. So from here like we can easily calculate the currents during like off and on period. So case A, right, when this II is like 5 amps, so what happens then? We can replace this 5R, this is R, this is a voltage source. We can replace, what is this? This is 2.5 by R, 2.5 R, and this is a complete, this is VO and this is IO, right? So what is VO? VO is basically 2.5 R only, right? And what is IO? IO is 5R minus 2.5 R divided by R, which is equals to 2.5 amps only. So one thing we can see, this is also IC, right? IC. So this is positive, right? So it will charge the capacitor. So VC will increase, which will tend to increase VO, right? So from here VO will slowly try to increase. Okay, now in case B, right, when II is 0 amps, so when II is 0 amps, this is 0 times R equals to V, so short circuit, right, not open circuit. Just be careful about that. This is short circuit. We have voltage source which is 2.5 times R and R, and our direction of current is this. Okay, so our direction of current is this. So what is IO? IO is minus 2.5 by R, which is minus 2.5 amps. So here like what we see is, and what is VO? This is VO, right? And like VO is 2.5 R only. It will reduce because like this is IC negative, hence VC will reduce, VO will reduce. So basically it will ripple around that 2.5 R only, and like IC, its goes from like plus 2.5 to minus 2.5. So let's draw the like waveforms, rather simple. So this is around 2.5 R only, okay, and this is around like plus 2.5 and minus 2.5, okay. So what will happen? Will charge, then discharge, charge, then discharge and charge, okay. So this will keep on happening, and for the current, right, it will suddenly go to 2.5, then slowly reduce, like from here slowly reduce, then again suddenly go to minus 2.5, then slowly reduce. Like why is like current will try to go towards 0, right, steady state, so it will go towards 0, right, so that's why. So here also suddenly increase, then go towards 0, suddenly decrease, then go to 0. So this will be like the waveform for this current and voltage for like the first case. Now for second condition, right, when T is much greater than RC. So this is also rather simple condition, just solving it real quickly. So we have this voltage source plus minus I times R, this is R, this is C, this is VO, and this is IO, okay, this is IO. So like what will be like the current, okay. So what will the current, like initially IO of 0 plus, like what is IO of 0 plus? Initially we are applying a voltage of 5R, and this VC of 0 plus is 0, hence VO of 0 plus is 0 volts, hence IO of 0 plus will be basically I into R divided by R, which is I only, which is equals to 5 amps, right. So initially there will be 5 amps of current, as the here the input source is on, like this is equals to 5 times R. Like in this case, let me write this, a case when II equals to 5 amps, right. So II equals to 5 amps, right. So now what is happening, basically it will try to charge the capacitor, because like IC is positive, hence VC will increase, so which will try to charge the capacitor, and IC will reduce, okay. So next what will happen, next like it will reach steady state, right, it will reach steady state. So at steady state IO of T1 minus equals to this will be open circuit, so basically it will be 0 current, right. This is 5R, this is R, this is VO, 0 amps, okay. This is at T equals to 0 plus, this is at T equals to T1 minus, okay. So this will how the circuit will look like basically. So what is VO of T1 minus? It is basically equals to, like the drop across here is 0, right, across here drop is 0, so it will be equals to VI only, which is 5 into R, okay. So VO will go from 0 to 5R, and like IC will go from like 5 to 0, okay. Next case B, when II equals to 0. So this will be short circuited, this will be like charge to some voltage 5R, and this is R, right. So like we are assuming current here, and this is VO. So what is IO at T1 plus? IO at T1 plus, right, it is basically like 5R by R with a negative sign, because current is flowing from here, right, and our direction is opposite, so it is minus 5 amps, so which is equals to IC also, IC which is negative, hence VC will reduce, which will reduce, VO will reduce, okay. So what is VO? VO is only plus 5R only, right, VO is only plus 5R, okay. Now what is happening, basically it will reach steady state, which is everything becomes 0, right. So this is VO at T1 plus, okay. So at steady state how the circuit will look like, this will be circuit, okay. T equals to T minus, okay. So T equals T minus, this will be circuit. So like what will be the values, basically IO of t minus equals to 0 amps, VO of t minus equals to 0 volts. So like this will be the waveform. So what is happening, basically let's plot the waveforms. So VO from 0 it's going to 5R, then from 5R it's going to 0. Okay, so basically we have already plotted this in previous example. It's going to 0 to 5R, this go to 0. Okay, so this is 5R, this is t on, this is t. Okay, and what for IO, what is happening, IO is rippling. Okay, so from here, right, 5 amps it's going to 0, then from minus 5 amps again it's going to 0. So from 5 amps it's going to 0, again from minus 5 amps it's going to 0, from 5 amps it's going to 0, minus 5 is going to 0. Okay, so like this will be the circuit. Okay, we have already solved this, so like I'm not going to too much here. Now let's go for the next question, right? Okay, coming to next question, right? Like in this question, does the capacitance and resistance, both of them has been interchanged, right? So can we apply the same superposition concept here? Like the answer will be no. Like why no? We can apply it, but we won't be able to find this current then. Why? Because up here in the previous question, right, in the previous question we applied superposition and changed this, but like the current through this also got changed. Like here this is not the current, like through what the current is through, let's say IR, right, and this is IR2, right, both of them are not same. Okay, so both of them are different, but this IO is equal to IR. Okay, but that is different. So as we have to find the current through this only, and this part we are changing, that's not an issue in this question. But like in this question, right, in this question we can't apply superposition as we have to find the current through the R. Okay, so what we can do is, like one thing we know, that the VO, right, VO will be same. Why? Because like here we are also taking the VO through this parallel combination, and this VO will be same, right? Here also this VO will be same only. So we have already found out the VO from the previous case, right? What is VO? VO basically is in the first case, right, VO is around 2.5 R, right? It ripples around that. Okay, so here also the VO will be around 2.5 R only, VO average. Okay, it will be 2.5 R only. Okay, like why? One thing you can do is like find it for steady state, right? At steady state the current through this is 0, whole current flows through this. So what is VO average? So VO average will be equals to IR average times R, right? Because the average current through this is 0. I am writing the equation II equals to IC plus IR, right? Now if I take the average, II average equals to IC average, which is 0, plus IR average. So like what is IR average? IR average equals to 2.5 amps only. Okay, 5 by 2, 2.5 amps. So like now what is VO average? Basically II average times R, right? So it is 2.5 times R. Okay, so like that's how you got this. In previous example also you can solve like this also. I am solving it with different methods, okay, so that you can understand all the methods. So like we got this VO average. Now like current is easy, right? Current is just IO equals to VO by R, right? So it's same only. Okay, so I'm not drawing it again. What will be the VO average? So initially what will happen? Initially when this source is on, right, this will charge this cap, and then this will slowly discharge, right? This will discharge. So like what will happen, as this is charging, so VO will increase, and then when this is off, this is discharging, so VO will decrease. So exactly that will happen. So it will increase, decrease, increase, decrease. Okay, so this is around 2.5 R, and for this also same, from 2.5 amps it will increase, decrease, increase and decrease. Okay, so basically that's what will happen for both of these waveform. Now let's go for the second case. Second case also it's same only. Basically here we have plotted the VO, right? It will be replica of this only. Okay, because it's same, and just divide by R, then we find the IO. So I will just simply copy this, okay, and take this over here, because I hope like you can do the analysis by yourself. Like this is one which I am leaving on you, so I don't want to like waste time of you guys. So basically, let me get it to the next page. What is happening? We have this II, right? We have this II which is, let's say, 5 amps. So this is the C and this is the R. So what is happening? This 5 amps initially will flow through this, then it will flow through the resistor, because initially the capacitance will be short, right? So what will happen? What is IO initial? IO 0 plus is initially 0. IO like T on minus equals to 5 amps, and IO like we can solve from here only. T on plus, what will happen? This is open, right? And this has whole charge of 5R, because the voltage through here is 5R at steady state, right? So this will be get charged to 5R. So this is 5R, this is R. So what will happen? IO of T on plus, current will flow through here, it's in the positive direction only, so it should be 5 amps. Then IO of T minus equals to 0 amp. At steady state it will totally discharge, okay? So basically it will be like same only. If I just copy this, right? So the waveform will look like similar only, okay? So I have solved this question a bit in a fast manner to show you like you can solve this in a fast manner also, okay? Okay, so the next question has a inductor with a current source. So in this question I will like solve it like rigorously, right? So like what will happen in this question? Let's solve it for the first case, right? When t is much less than the time constant, that is L by R. So like let's first assume for the case A, right? When II equals to 5 amps, okay? So this is 5 amps of current, and initially what is happening? The inductor has 0 amps of current, right? Inductor has 0 amps of current. So this is 0 amps of current as it is uncharged, and this is R, right? So what is the current IO? This is IO and this is VO. So IO equals to 5 times R. So initially IO is 5 times R, right? Let me write this like this is at t equals to 0 plus, okay? So what is VO? VO is sorry this is I is 5 amperes, okay? And what is VO? VO is 5 times R, IO times R. So here VO is VL, which is positive, right? So as VL is positive, IL will increase slowly and VL will go towards 0, okay? So like IL will slowly charge. To what amount will it charge? Let's say like from 0 IL charge to IL, from 0 it went to 1 amps. So at 1 amps, what is the circuit look like? Here we have 5 amps of current, this is 1 amp, and the direction of IL is this, because it is charging, right? It is charging from plus minus here, so IL will go in towards the positive, it is charging. So direction of current will be this will be 1 amps, and this is R, right? And this is VO. So what is happening? What is IO right now? IO is 4 amps, and what is VO? It is 4 times R. So like what we are observing is basically it is decreasing, right? VL is decreasing, so the charging rate will decrease and the current through the inductor is increasing, and IO is also reducing. So for the case B, right? For the case B, when II equals to 0 amp. So when II equals to 0 amp, what is going on? Here this is 0. Here we still have the inductor current, right? So it won't change suddenly. So this is for the condition at t equals to t on plus. So this is going like this. Then this is resistor R, this is 1 amps. Now what is happening? What is VO, right? Our initial direction of current is this, but 1 amps of current is flowing through here, right? So what is VO? This is like a plus minus resistor drop. So VO is basically minus 1 times R, which is minus R. So VO suddenly changes from 4R to like minus R. And what is happening? What is VL this time? This is also VL, right? VL. So as VL is negative, right? So IL will reduce. Okay, IL will go to a 0, but obviously it can't go. There isn't any time. So let's say like it went from IL reduced from 1 to 0.5 amps, right? This is IL reducing. Okay, from 1 amps to 0.5 amps. So now what will happen? Let me draw the circuit for case C, right? When II equals to let me draw for case C, right? When II equals to this 5 amps of current, 5 amps of current, right? So as this is equals to 5 amps of current, so like this inductor has still 0.5 amps of current. We have resistor here. So what will happen? Basically here 5 amps is coming, 0.5 amps is going out. So what will be the current here? Basically 4.5 amps, right? So IO equals to 4.5 amps, VO equals to 4.5 times R. Okay, so again VO is positive, right? So VL is positive, so IO will IL will increase and IO will decrease. Okay, so again we are seeing that the like charging rate has reduced. Initially it was here initially it was 5R, it came to like 4.5R, right? So again now what will happen? From 0.5, right, it will not charge to 1.5. let's say it charged to 1.25 amps, like similarly, like similar to the previous cases how we solved. So again let me draw it for the D case when II is again equals to 0 amp. So this is 0, this is 1.25, and this is R, right? And this is VO, and this is IO. So what is VO? VO is basically IO times R. So IO is negative 1.25 right now, negative 1.25 times R, and IO is minus 1.25, right? So we see that the charging rate has increased. Here it is minus 1.25 R, and here where is IO? In this case, right? Yeah, here like it was minus R only. Okay, so it increased, so the charging rate is increasing and the discharging rate is decreasing. Okay, sorry, I told you wrong. The charging rate is reducing and the discharging rate is increasing. So obviously at steady state we know the answer, when the charging rate will be equal to discharging rate, right? So what will happen at steady state? At steady state the average voltage across the inductor will be 0. So let me draw the circuit. This is II, this is the inductor, right? L, this is the resistor, this is VO. So what is happening? If I like write the equations, this is IL and this is IO. So II equals to IL plus IO, right? Now one thing we know, what is IO? IO is VO by R, right? And what is VO? Like what is IO? It is VO by R. And what is VO? VO is VL by R. Okay, so what we can do is we can write II equals to IL plus VL by R. Now if we calculate the average current, okay, if we calculate the average current, what will happen? II average equals to average plus VL average plus R. Okay, so what is II average? It is 2.5. What is IL average? It is some like finite value, right? Because it will at steady state the average voltage will be 0, hence this will be 0 by R, hence IL by average equals to 2.5 amps. Now let's find the conditions for the voltage, right? What will the voltage is? So like let me draw like case A, when II equals to 5 amps, right? So when II equals to 5 amps, what is happening? When II equals to 5 amps, this is basically 5 amps. What is the current? IL 2.5, right? This is 2.5 amps. This is the resistor, right? This is the resistor. Okay, and this is some current. So what is this current? This is 2.5, right? And what is the voltage? VO. So what is the IO? IO is 2.5. What is VO? VO is 2.5 times R. So as we can see, like this is some positive voltage, right, which is equals to VL. So VL is positive, so it will charge. So like IL will increase, hence like IO will reduce, right? So IO will slowly reduce, which will also tend to reduce VO, right? VO will also reduce. Okay, so this is like the first case. Let's go for the second case. II equals to 0. So for the second case, right, what is happening? This is 2.5 amps. This is R. Okay, so what is IO this time? And this is VO, right? So IO is basically, IO is minus 2.5 amps, right? It is in the opposite direction. Okay, and what is VO? VO is also minus 2.5 times R. So this is VL, which is negative, hence IL will reduce, hence IO will reduce, hence VO will also reduce. Okay, but from negative direction it's going to a 0, steady state, right? So how will the waveforms look like? So basically if we like draw the waveforms, so IO, what is happening? Basically it is rippling around this 2.5, then it's slowly reducing, then also here minus 2.5, then it's slowly reducing, right? So what is happening? 2.5 is slowly reduced, then minus 2.5 slowly reduced, increase, then reduce, right? 2.5 minus 2.5 amps. Okay, so like this will be this current. Now what is the voltage? Basically replica of the current only, because VO equals to IO times R. 2.5 R and minus 2.5 R. Like you can verify that the average voltage across the inductor is 0. Here also this is 0, right? Average voltage is 0. Okay, so basically this will be the plots for IO and VO. Now let's go for the second case, which is when time period is much greater than L by R. So when time period is much greater than L by R, what will happen? Again, like I will try to solve it in a fast manner. So this is when case A, right? II equals to 5 amps. So this is 5 amps. This is the inductor. This is the resistor, right? RL. So what is happening? Through here initially it will be 0. Initially what will be IO? 5 amps, right? So initially IO 0 plus is 5 amps only. Whole current will flow to the resistor because the inductor is open circuit, and VO equals to 5 into R. Okay, VO equals to 5 into R initially. So this is VL. VL is positive. VL is positive. As VL is positive, hence IL will increase. So at steady state it will be short circuit, right? So what will happen at steady state? Let me draw the circuit. Steady state. Here this is short circuit. This is R. Whole current flows through here only, right? This is plus minus 0 volt. So basically what is happening? VO of T on minus equals to 0, and IO of T on minus is also equals to 0. It only follows the voltage, right? Okay, IL of T1 minus, what is it? 5 amps, right? So this is basically for the first case. Let's go for the second case. B, when II equals to 0 amp. So when II equals to 0 amp, right? So when II equals to 0 amp, this is the inductor and it has some current, right, of 5 amps and it is R. So what is happening? This is flowing in the opposite direction. IO is this, right? IO is this, and we have 5 amps here. So IO of T1 plus equals to 5 amps. VO of T1 plus equals to minus 5 times R. Okay. Sorry, this is negative. This is negative, and VO of T1 plus is also negative, right? So it suddenly went to negative. Then what will happen at steady state? Like this will become short, right? Total discharge, as like this is negative, right? This is negative, so VL is negative, so it is discharging. So let me draw this. This is R and this is short, right? So this is VO. So what is happening? VO at T minus equals to 0 volts, IO at T minus equals to 0 amps, and IL of T minus equals to 0 amps, right? So like these are the cases. So let me draw the waveforms. So initially what is happening? IO is initially total 5 amps, right? Initially IO is 5 amps. Then what is happening? It's going to 0. Then what is happening? It is going to minus 5 suddenly. Then it is going to 0 again. So how is IO changing suddenly? This is inductor. How can current change suddenly? It can change currently because we are taking it across resistor, and the voltage is suddenly changing across the like inductor. Hence voltage is proportional to the current for resistor, hence it is changing, right? So what is happening for the current? So from 5 it's going to 0, then from negative 5 it's going to 0, then from 5 0 negative 5 is going to 0. Okay, 5 amp negative 5 amp, right? This is T1, this is T. Okay, so that's how this current waveform will look like. Same for voltage, right? Same from voltage. This is basically the inductor voltage which is changing suddenly. Okay, this is 5 into R, this is minus 5 into R, right? So here also, if you see, like if you compress the waveform, you will get the same like same waveform for the T much less than like L by R, right? So what is it? So here if you see, we compress it, we get it's somewhat like decreasing, not quickly, it can't decrease quickly, so it's decreasing, then suddenly it changes to negative, then it like decreases to 0, right? Here same waveform we are getting decreasing. Obviously it isn't getting enough time, so it decreases a small amount, then suddenly changes, then it suddenly decreases towards 0, then again it suddenly changes, right? That's why it's like it isn't getting enough time to change. So this is basically it for this circuit. So let's go to the next question. Okay, in this question what can you do? Like we can simply use the source transformation again. So because IO has to be found out here, not like in this resistor. So like what will happen here, basically if I do the source transformation, right, this will get converted into plus minus II times R. This is R, this is L, this is VO. Okay, so like this will happen now. What is like now we can easily solve this, like we have already solved this in previous case I believe. So I will directly solve this. Like inductor will reach steady state, the average voltage across it will be 0, so VL average will be equal to 0, right, at steady state. So for first case, right, when II equals to 5 amps, what will happen? Let me first like write the condition for which this happens. So if VL average is 0, so this is the current II and this is the current, right, like this is IR. So II equals to IR plus IO, right? So like what we can do is, basically what is II? II is only 5 amps and IR is VL by R plus IO. So if I take the average, VL average will be 0, so II average equals to VL average divided by R plus IO average, right? IO average. Okay, so what will be VL average will be 0, so IO average will be equals to IO average, which is 2.5 amps. Okay, so this is basically the like average output current. So the what we know is this output current, right? The average value of this is 2.5, right? Or what you can do is directly do it from this circuit also. You can do it both ways, right? I solve it like this. You can do it both ways. Let me like clean this up a bit. Here we have this. Okay, so now let's go to the next page. Like we know the IO average, right? It is 2.5 amps. So let me like solve it. So when it is 2.5 amps, right? So here we have the inductor. So this is 2.5 for case A, right? Case A, when II is 5 amps. So this is 5 amps. This is resistor. This is inductor, right? So what is the current through here? 2.5. What is the voltage? VO, and this is IO. So VO is basically 2.5 times R. Okay, and what is like IO is 2.5. IO is 2.5, but what is happening here is as VO equals to VL, so it is positive, right? It is positive. Slowly IO will increase. If IO increases, IR reduces, hence VO reduces, right? So this will happen for the second case, right? For the second case, when II equals to 0 amps, this is open circuit, this is R. Again the current through here is 2.5 amps. Okay, so what is happening? This is VO, right? So what is VO? Now the current is flowing like this, so this will be plus minus, hence VO will be negative. So VO will be minus 2.5 times R, and IO is still 2.5, right? But this time this is VL, right? This is VL, this is negative. So what is happening? So like IO will reduce, hence VO will also reduce. So it is reducing. So like what is happening? Let me like draw the waveforms for this. So what is happening? Let me draw the waveforms for this. Okay, so if I see it right here, what is happening is that basically initially what was VO was 2.5 R, right? Then it is reducing, then it went to suddenly minus 2.5 R at t equals to t1, then again it reduced, going towards steady state. So what is VO? 2.5 by R, reduce, then minus 2.5 by R, then again reduce, and this is keeping on going on. Okay, 2.5 R and minus 2.5 R, right? So like this is happening, and IO is same only because no IO is not same. Basically IO, it's initially 2.5, then it is reducing, and here also again IO is 2.5 only 2.5, then it reduces. Okay, so it is like at steady state it is around 2.5 amperes, right? So like it's like it will repel around 2.5 amperes. So this is 2.5 and ripple around 2.5, right? Charging and discharging, right? So this is 2.5 amps. Okay, so IO and VO will be like this. This is only like same as we did in the previous for voltage. So I'm doing it a bit quickly. So now let's do it for t much greater than L by R. So again, like what will happen? We have this II right here, II, and this is the resistor, and this is the inductor. So what will happen initially? This is IO, this is II, and this is IR. So initially what will happen is, initially IO of 0 plus, right, will be 0 in the case A, right? When II equals to 5 amps, it will be 0 amps. Now let me draw the circuit for this. Basically this is 5 amps, this is a resistor, this is open circuit. So here it is 0 amps, here whole 5 amps flows. Okay, so this is 5 R drop, this is VO. So VO is 5 times R. Okay, this is just a initial case, right? This is at t equals to 0 plus. Now at t equals to infinity, what will happen? As it has enough time to get settled, so this is 5 amps, this is R, this is shorted, and whole current will flow through this. Okay, this is 0 volts, right? So current across this is 0 amps. So IO T1 minus equals to 5 amps, and VO T1 minus equals to 0 volts. Okay, so this is at t equals to infinity. Okay, so this is basically at t equals to infinity. Sorry, not t equals to infinity, this is at t equals to T1 minus. So what is happening after this? At B, right, when I equals to 0 amps, what is happening? Basically this is 0, this is R, and this inductor has been charged to total 5 amps of current. So this is 5 amps of current. Okay, so what is happening? This is discharging, right? So like this is discharging. So what is IO? IO is still 5 amps, but VO this time is negative, right? Because the drop is like this only. So like IO is still 5 amps. Let me write this for T on plus, still 5 amps here at t equals to T1 plus, right? Still 5 amps. So what is VO? VO is minus 5 times R, which is equals to minus 5 R, right? So VO is minus 5 R. So like we have calculated this is at T1 plus. So what is the circuit for like T minus? Basically this becomes shorted, so no current flows, right? No current flows. So this is plus minus 0 volts. So basically IO equals to 0 amps, and this is at T minus, right? This is T minus, right? This is 0 volts. So like now we can draw the waveforms, right? So how the waveforms would look like? So waveforms basically here initially what was happening? Initially VO was 5R, then it went to 0, then from minus 5R, then it went to 0. So voltage across inductor will change suddenly, but current across it won't change. From 0 it went to 5, then from 5 it again decayed, right, to 0. So from 0 it went to 5 particularly, then again decayed. So this is basically the same waveform that we already plotted, right? So this is 5 amps, and here what is happening? From 5R it is going to 0, then again minus 5R it is going to 0. So 5R it is going to 0, minus 5R it is going to 0, 5R it is going to 0, minus 5R it is going to 0. So basically this is a minus 5R. Like again, if you compress this waveform, you will get the same waveform that we got here, right? Rippling around minus 5R, like 2.5R and plus 2.5R for VO, and IO is settling to some value. Okay, so like that's it for this question. Like you can do it with intuition directly. Okay, I have told you like the method in like first few examples. So that's it for this question. Let's go to the next question. So now let's solve this question. So here for ease of our calculation, let's take R1 equals to R2 equals to R. Now what will happen? Like let me tell you the intuitive approach here. Basically what will happen is like this current source initially when it's on, right? so this will become short and some current will flow through here, so this will charge the capacitor, right? Like the voltage across the capacitor will increase and hence the current through it will decrease, hence the IO will increase slowly, okay? But this will slowly charge the capacitor. Then like when this input is off, then slowly this capacitor will discharge, right? But obviously the discharging rate will be less than the charging rate initially, right? Then what will happen, as this is the 5 amp source, right? 5 amp is charging this, and for discharging only the capacitor is present, okay? So it will be less. So like at steady state, what will happen, it will like reach steady state at charging rate equals to discharging rate. So then what will happen is basically like the average current through this will be 0, right? So if average current through this is 0, the drop across this R1 is 0. Now this whole VC comes across this, right? And what is the drop across this? It is basically the like IO, like what is II? II equals to IO plus IC, and like II average will be equals to IO average, as IC average is 0. So IO average times R equals, that is II average times R, 2.5 R. So that will be the VO average and that will be the VC average, right? So from there we can find the currents and all those things, right? So this is basically the like the intuitive approach what should go in your head, right? So let's solve this circuit rigorously here. So for the first case, when time period is much less than R1 plus R2, this is 2 RC, right? First case when II equals to 5 amps. So if II equals to 5 amps, right, this is 5. Initially what is happening, short. Okay, so this is VO. So this is at t equals to 0 plus. What is IC? We will just write the IC and VC, right? What is IC? IC is 2.5 amps. This is IC, which is positive. What is the VO? 0. As it is positive, VO will increase, right? Sorry, I meant VC. VC will increase, right? So if VC increases, what will happen? Basically it will try to reach to some steady state. What will be the steady state? Steady state will be basically 5 times R, because what will happen, this will open circuit, right? This is the resistor, this will open circuit, this is R, and this is 5 amps, right? This is 5 amps, this is R. So like what will VO go to? VO will go to 5 times R, okay? Steady state this is. So, but obviously it won't reach there. Why? Because like the T is much less than RC, right? Time constant. So obviously it won't reach there. What will happen? Basically let's say VO, like not VO, VO is VC here, obviously VC steady state. Let's say VC goes from 0 to R, right? R volts, it charges up. Now what will happen next? So here, like if I draw the circuit at R, right, this is R, this is R, and this is VO, and this is 5 amps. So let's like do the KVL. This is IO, this is IC, right? So IC plus IO equals to 5, and if I like do a KVL, right, this is KCL. So what is like R minus R, and this is also minus IC times R plus IO times R equals to 0. So this equation will become like IO minus IC equals to 1. So IO equals to 3 amps, IC equals to 2 amps. So IC has reduced, right? IC has reduced. So if IC has reduced, what will happen? Obviously the charging rate has decreased, right? Now next what will happen in the case B, right? In the case B, when II equals to 0 amps. So if II equals to 0 amps, right, what is happening? We have this resistor, this has been charged to R, and this is also resistor, okay? This is VO. and like this is IO, but we are mainly interested in the IC and VC. So what is IC? IC's direction is this, right, coming into the positive terminal. So what is IC this time? IC is minus R by 2R, which is minus 1 by 2 amps, right? So IC is minus 1 by 2 amps. And what is VC? VC is R only, right? But as IC is negative, VC will reduce, right? So it is discharging, and where it is going, VC is trying to go towards 0 volts, but obviously it won't go there. Let's say it goes to R by 2. VC goes to R by 2. Okay, so VC goes from R to R by 2. Okay, now next what will happen? Next, when II equals to 5 amps, again we have current of 5 amps here again. Okay, this is resistor, this is R by 2, this is R, this is R, right? And here's view. Okay, and this is the like the IC. So what is the IC right now? Let us like apply the KCL. So if I apply the KCL, IO plus IC equals to 5, and if I apply the KVL, right, KVL, if I have the KVL, then minus of R by 2 minus of IC times R plus of IO times R equals to 0. So IO minus IC equals to 1 by 2 amps. IO minus IC equals to 1 by 2 amps. So what is like IO right now? IO is 5.5 by 2. So IO equals to 2.75 amps. Okay, and what is IC? IC equals to 2.25 amps, right? So we see that IC has been reduced, right, from 2.5 amps. Initially what was IC? Initially it was 2.5 amps, right? Here if you see, initially IC was 2.5 amps, but still it is positive. Obviously it will still get charged, but charging rate has reduced. And like for the next case also, if I see for the next case, for this is C, this is then for D. Let's say like it discharged, right? To how much it discharged? Obviously it won't get discharged totally, like obviously VC won't get like charge from 0.5 R to 1.5 R, right? It won't get charged to that. It will get charged somewhat late. Let's say 1.25 R. It get charges to 1.25 R, right? So next what will happen? Next, let me like draw for the circuit when II equals to 0 amps, right? II equals to 0 amps. So if I draw for the circuit when II equals to 0 amp, right? So this is resistor again, this is 1.25 R, this is R, this is R, this is VO, right, and this is IO. So basically what will be the IC right now? IC will be minus 1.25 R divided by 2 R, which is minus 6.65. So discharging rate has increased in the negative direction, right? So discharging rate has increased. So like at steady state what will happen? Steady state, obviously this IC of charging, right, charging, like the magnitude of this will be equals to IC of discharging, okay, will be equal. So this is steady state. Okay, so what will happen? So as when will this condition happen? Let's I've already told you intuitively, when this gets charged to some voltage. Let us first draw the circuit right now. R, C, II, okay, so IO, IC, right? IC. So like now one thing to observe at steady state, right? Steady state, IC of average will be equals to 0, right? So II average will be equals to IO average. So like what will be like the IO average? IO average equals to 2.5. And what is VO average? VO average simply equals to 2.5 times R, right? Simply it is a resistor, so it will be that only. So let's find the like currents right now at those instance. Now if I draw the circuit for case A, right, when II equals to 5 amps, so when II equals to 5 amps, right, so this is 5 amps. What has this like charge to? This has charge to, I haven't written that. Let me first write that. Actually here what will happen is that like this is VO average, right? And what is VO average? What is VO average? This is VO average, right? VO average, VO equals to this IC times R plus VC, right? Now if I take the average of this, VO average equals to IC average times R plus VC average, right? So what is IC average? It is 0, right? It is 0. So what is like now VC average? VC average is basically VO average, which is equals to 2.5 R. So VC average equals to 2.5 times R. Okay, so 2.5 R. This is R, okay, and this is VO, right? This is VO. So like now let's draw for the first case, right? So what is happening? How to calculate the IO right now? Again, simple, apply KCL and KVL. So if I apply KCL, right, IO plus IC equals to 5, and applying KVL, right, KVL basically minus 2.5 R minus IC times R plus IO times R equals to 0. So IO minus IC equals to 2.5, okay, 2.5. So what is IO? IO is 3.75 amps. What is IC? IC is 1.25 amps, right? So IC is positive, right? So obviously VO will charge. If I write in IC is positive, so not VO, VC will increase. Now if VC increases, right, just think this, VC will increase. What will happen if IC is, so if VC is increasing, so what will happen? IC will reduce. Like when capacitor charges, the current through it reduces. So if IC reduces, right, so IO will increase, right? IO will increase. So this is the first case. Now let's go for the next case. Next case, what is happening when II equals to 0 amps? So if II equals to 0 amps, right, this has some charge. What has this charge to? 2.5 R, 2.5 R, this is R. So what is IC? No, what is IO? IO is still the same only, like no, IO has changed here. Like what is IO? IO has 2.5 R by 2 R, which is 1.25 amps. What is IC? IC IC is minus 1.25 amps. Obviously this is IO and this is IC, okay. So obviously this is a source free network, so obviously it will discharge. That we already know. I'm just like writing everything, okay. So obviously it is like discharging, so VC will reduce, hence like IO will also reduce, everything will reduce, okay. So here like we are seeing this. Now like IO is moving from 3.75 to 1.25, right? I was moving from there. So let's like draw the waveforms now. So IO is moving from 3.75 and then it's slowly increasing. Okay, let me bring it down a bit. Then suddenly it reduces to 1.25 amps, right? 3.75 to 1.25, and then it reduces, then again it increases, and it like goes like that only. Okay, so this will be basically the case, right? This will be the basically the case. Okay, so it's rippling around 1.25 amps and 3.75 amps. So now you may ask that why isn't this like average current 0? Like capacitor current should be 0, right? Why isn't like this average current 0? First thing to note is that obviously this is not the capacitor current, and next thing is that if I write this, right, if I write this here, like what is VO, and like VO will follow IO only, right? So VO will be same also. It will ripple around these 2 points, right, only multiplied by R. Okay, so it will ripple around this only. This is 3.75 R, this is 1.25 R, right? So it will ripple around this only. So what is happening basically, this is IC times R plus VC, right? This drop, right? IC times R plus VC. VO is that. So what is happening? IC average is 0. IC average is 0, but IC is itself rippling, right? It is rippling to where basically initially what was IC here? IC here was 1.25 and then it went to minus 1.25. So it goes from 1.25 to minus 1.25. It's rippling around certain range, right? Between between 0, in between 0 it's rippling, but here IO gets shifted to like 1.25, right? How? Because IO gets shifted to 2.5 due to this like capacitor, right? As the average voltage across this is 2.5 R. So if I apply again, like I VO average, right, equals to 0 plus VC average. So due to this like capacitor, the average voltage gets shifted up, hence the current also gets shifted up. So that's why the waveform is coming something like this. Okay, so here the average voltage is 2.5, but it's shifted. Okay, it's not rippling around 0, as this is not the capacitor current. So let's go for the next case, that is T much greater than R1 plus R2. So for T much greater than R1 plus R2, let's solve this a bit quickly. This is 5 amps, right? This is R, this is C, this is R, right? So what will happen initially let me draw the circuit set. Initially obviously this will get short circuited. See, so initially when this is II equals to 5 amps, so IC equals to 2.5 equals to 2.5 amps. Okay, so IC equals to IO equals to 2.5 amps. Now what is happening at steady state? Like we have already drawn the circuit. This is at T equals to 0 plus, this is at T equals to T1 minus, right? At T equals to T1 minus. Okay, so what is happening at T equals to T1 minus? IC of T on sorry, this is not plus, this is minus, equals to 0. IO of T1 minus equals to 5 amps. VO of T1 minus equals to 5 R. Here VO of 0 plus equals to 2.5 R, right? So it's going from 2.5 R to 5 R. Okay, so what is happening for the next case? For the case B, right? Case B, when II equals to 0 amps. So basically this is 0, this is R. What is the VC right now? What is the VC right now? So VC equals to VO equals to 5R. So basically this will be 5R, and this is R, this is R, this is at t equals to t1 plus. Okay, so t equals to t1 plus, we are getting the circuit like this. This is basically VO, this is IO. So what is VO right now? Let me first calculate the IO. What is IO? IO is 5R by 2R, which is 2.5 amps. Okay, now what is IC is negative. Okay, IC is negative, it will discharge. IC is minus 2.5 amps and VO is 2.5 times R. So IC will reduce. Okay, VC will reduce, VC reduces, IO reduces, IO reduces, VO reduces. Here, like as this is positive, right, it will charge. As this IC is positive, it will charge. So like IC will reduce, IO will increase, right? IO will increase. Okay, so VO will also increase. So what is happening? Initially IO was 2.5, then it tries to increase to 5, right, to 5 amps. Then from 5 amps it suddenly goes down to 2.5. Then what happens at steady state? What is at steady state? This is open, the cap is also open, this is R. So at steady state the current is 0 amps. Steady state the current is 0 amps. So obviously IO of t minus equals to 0 amps, VO of t minus equals to 0 amps, everything is 0. IC of t minus equals to 0 amps. Okay, t minus. Okay, so this is at the steady state. So what is happening? It is starting from suddenly 2.5 amps, very fast charging to 5 amps. Okay, this is amps, this is amps, and then again coming down to 2.5. Then it is very fast discharging to 0. Then again suddenly increasing to 2.5, right? Suddenly increasing 2.5, then very fast charging, then suddenly coming down, then discharging. Okay, so this is 2.5, this is 5 amps. Okay, so this is basically the waveform for this current. The voltage will be just the replica of this, decreasing, decreasing. Okay, so this is 5 times R and this is 2.5 times R. Okay, so now what we can observe is basically if we we are plotting it for the t much greater than 2 RC, right? Now if we compress this, we'll get the same plot when t is much less than, because here it isn't getting enough time to charge and discharge, right? Suddenly decreases then discharges. So here what happens? It charges, suddenly decreases, then discharges. Here also same thing is happening, charges, then stays. As charging time isn't enough, so it won't get fully charged, then suddenly decreases, then discharges. Exactly that thing is happening. So from this you can get an intuition of what will happen in the t much less than RC, which is basically compression in time domain. Okay, so basically that's it for this question. Let's go to the next question. Now let's solve the next question. So in this next question we have the same circuit only. So what will happen, one thing to remember is the output voltage will be same, right? But the IO will change. What will IO change to? Basically it will ripple around that 1.25 and minus 1.25. okay, so basically it's the same circuit only. I will not solve it that much rigorously. Just let me apply source transformation here, because we have the resistor. Okay, so simply if I apply source transformation, right, so source transformation. What will happen? This will get converted into plus minus II times R resistor and C and R. So what will be the average voltage across the capacitor? So the average voltage across the capacitor, right? So II times R equals to IO times R plus VC, right? Now IO average is 0, right, as this is capacitor current. So II average equals to 0 times 2R plus VC average. Okay, so what will happen? Basically VC average equals to II average times R. II average times R we have missed here. Sorry, let me take this times R. Okay, so II average times R. So II average is basically 2.5 only. So 2.5 times R. Okay, this is VC average. Now let's draw for the first case and second case. So A. So what is A? This is II average. So we have let's assume now we have found the VC average, right? Now we will draw the first circuit only, which is with current source. So this is like the circuit. So what is happening when II equals to 5 amps? When II equals to 5 amps, right? If II equals to 5 amps, IO equals to how much? We will calculate. This is some IR. So I R plus IO equals to 5 amps. And what is this KVL, right? Applying KVL minus IR times R plus IO times R plus 2.5 R IR minus IO. Okay, so if I find IR, what is IR equals to 3.75, which came in the previous question also, and what is IC and IO equals to 1.25, right? So it is 1.25, and in the next case it will be minus 1.25. Still I am solving it. Here what will happen when II equals to 0 amps, right? So I equals to 0 amps, this is R, this is R, this has been charged to 2.5 times R. Okay, so this is, what is this? This is 0 amps, right? So what is IO? IO this time will come out to be negative. Okay, what will be the negative value? It will basically be I equals to minus 2.5 divided by 2R, which is minus 1.25 amps. Okay, so I equals to minus 1.25 amps. So now we got it. What is VO? VO equals to IO times R plus VC equals to IO times R is minus 1.25 R plus 2.5 R, which is 1.25 R only. So here what was VO here? Here the VO, right? In this case VO equals to IO times R plus VC only, right? So let me take it to the next page actually. So what is VO equals to this IO times R? IO times R is 3.75 times 1.25 times R, which is 1.25 R plus 2.5 R, which is equals to 3.75 R. Now what is happening is basically the voltage is getting shifted by 2.5 R, as this average current is 0 through this. So the average voltage drop across this is 0. So the average voltage will come out to be 2.5 R, but it will ripple because due to this current, right? Current is rippling. So IO here is 1.25 amps. Okay, So let us what is happening also, one more thing, initially when this current is on, right, so this VC, right, this will charge as IO is positive. Now as IO is positive, this VC will increase, right, VC will increase. Now so it will slowly increase. What will happen? So IO will slowly reduce, right, IO will reduce. So IO will reduce, right, it will reduce. Here what is happening? Here as IO is negative, so like if IO is negative, right, VC will reduce. As VC is reducing, IO will also reduce, IO will also reduce. Okay, so let's plot the waveforms, right. So first let's plot for the IO, right. So where is IO going from? IO initially it is going from 1.25 and it is reducing to, then it is going from minus 1.25 and it is also reducing there towards the zero value, right, towards the zero value. So here 1.25, then reducing, and minus 1.25, then reducing. One more thing, like IO will try to go to steady state, right? And what is the steady state value? 0. So it will try to reduce towards 0, go towards 0, always go towards 0. So here also, in case of voltage, we can do that also. Here this is going towards 0. This is 1.25 and this is minus 1.25. Okay, so this is basically the IO. Now what is VO? VO will be the same plot only get shifted up. Okay, shifted up by 2.5. So basically if I just copy and paste this plot, right, copy and paste, I can't copy and paste, so but if I just copy and paste this plot, it will just be shifted by 2.5 R. Why? Because it has some extra drop of like IO times R, which is like here 1.25 times R and minus 1.25 times R, and with added of this. So what is VO? Let me write it. VO equals to IO times R plus this VC, right, and VC is 2.5 R, so it will get shifted up. So same waveform only shifted up. Okay, and this is the average value. I won't write the average, I will write this, the upper points and the lower points. So what is the upper point? Upper point is 3.75 R, right, it is 1.25 R, just get shifted by 2.5. So here, like if I have written it down here, it is 3.75 R and it is 1.25 R. So this is for the first case. Let's go for the second case. Second case, I will again do this a bit quickly. What is happening? Let me like draw the circuit. This is, let me draw for the t equals to 0 when we have II equals to 5 amps. I'm not using superposition right now. We can use that also. We can use simple analysis also. Okay. R, and what is happening initially? What will happen? This will get short circuit, right? This will get short circuit. So initially, what is this is IO and VO. What is IO? IO is 2.5 amps. Okay, and what is VO? VO is IO times R, which is 2.5 times R. So initially, this is the voltage. This is at t equals to 0 plus. Now what is happening at t equals to infinity, right? Not infinity, just before t on. Just before t on. This is a resistor. This is getting open circuit. 5 amps. Okay, so just before t on, what is happening? This is at t equals to t on. So like here, what is happening? IO is 0 amps, right? Current is 0 amps here, open circuit. VO is this, right? This becomes VO. So VO is this whole current flows through here only. So 5 times R. Okay, so it goes from like 2.5 to 5 R. Now let's go for the next case when this II is 0 amps. Okay, if this II is 0 amps, right? If II is 0 amps, so this is open circuit, right? These are These are, and this has some voltage, right? What is this voltage? 5R, right? As VO is VC, right? VO, the drop across this is 0, the drop across the resistor is 0, so VO will be VC only, right? VO will come here. So like this is what this is 5R, this is R. Now what is the IO? Like our direction of IO assumed here, so what will be the IO? IO will be 5R by 2R equals to 2.5 amps. Okay, it will be 2.5 amps. Now it is negative, right? It is negative. And one more thing, so IO is basically equals to IC, so IC, so it will reduce negative, hence like VC will reduce. So this all we already know. And like this is at t equals to t1 plus, right? This is at t equals to t1 plus. Now what is happening? Now basically it will reduce. And what is VO? VO is like here I have calculated the VO, right? Yeah, VO I have calculated. So what is VO here? VO is like this IO times R, right, in negative. Like IO is coming here only, flowing here only. So this is positive, right? So current is flowing through here. So this is plus minus. So VO will be some positive value. So it will be this is 2.5 amps of current, 2.5 times R. And at steady state, right, like at just T minus, this will be open circuit. This is R, this is open circuit, right? So this is open circuit, this is VO, this is IO. So what will happen? Basically like VO, this is at T equals to T minus, VO will be 0, IO will be 0, everything will be 0. Okay, everything will be 0. So let's now like plot the waveforms. So what is happening for VO, right? VO initially it is 2.5 bar, then it is going to 5 bar, then from 2.5 bar suddenly it reduces to 2.5 R, then it goes to 0. So from 2.5 R it goes to 5 R, from 2.5 R suddenly it increases to 2.5 R, then it goes to 5 R pretty quickly, then again suddenly reduces to like 2.5 R, then it decays, right, pretty fast. Okay, so this will be basically the plot. Okay, this is 5R, this is 2.5R. What is the IO? Like IO initially it is 2.5, then it goes to 0, then again it goes to minus 2.5, then it goes to 0. Basically it will like go around. Initially it is 2.5, then it goes to 0, minus 2.5, then it goes to 0, 2.5, then it goes to 0, minus 2.5, then it goes to 0. Okay, so if I compress this waveform, right, I will again get the same waveform in this case. But I think one thing I have made mistake is that here, like one thing is like when we are adding this, right, like IO times R plus VC, so like this VC is also increasing, that I didn't take care at that time. So VC is also increasing. What will happen is that this will just change a bit. Like if I change a bit, like we have to like match this, right? What is happening here? It's increasing, then suddenly decreases, then decreases, right? So initially what should happen is it should increase, right? So initially like should increase, then suddenly decrease, then again decrease, and this is how like the waveform will like, look like. So what I haven't taken care of is that like this one, right, this VC. So VC is also increasing as it is charging, right? So like and this IO is reducing, but VC is increasing. So like this will like be like that waveform only. Like if we compress this, we are getting that one, right? If we compress this, we are getting the similar type discharging, then suddenly changes sign, then like it is going towards 0. Okay, so like that's it for this question. Let's go to the next question. So let's solve this next question. So first I will solve this rigorously. Okay, so first like when for the first case, when t is much less than L by R, t is much less than L by R, what is happening? Basically case A, when this II, right? II equals to 5 amps, equals to 5 amps. So if I draw just T equals to T on, what is happening? This inductor has initially 0 amps of current. Okay, these are okay, these opens away, right? And these are, so what is the current through here? Current through here is 0 amps, so whole current will flow through here, which is 5 amps. So what is VO? Not VO, we just calculate VL and IL. So what is VL initially? VL initially is this whole drop, right? Whole drop across this is the VL, because drop across this is 0. So VL equals to 5 bar, which is positive, right? Positive. So it will charge the current through the inductor. It will charge the current. So IL initially is 0, okay, but slowly it will increase. Okay, so let's draw for the steady state condition. So for steady state, this is 5 amps. Inductor will be short. This is R, this is R. So here and here, right? This is 2.5 and this is also 2.5. okay, so both of them are 2.5. so what is IL of steady state? 2.5 amps, right? So obviously it will try to get to 2.5 amps, but it will not reach there as we don't have enough time, right? The time constant is much greater than the time period of the input. So what will happen? Let's say it's charged to 1 amps, okay, from 0 to 1 amps. I got charged, sorry. Okay, so what will happen when it reaches 1 amps? So again this will have 4 amps of current, so VL will be VL will reduce, so the charging rate will reduce. I'm directly drawing when II equals to 0 amps. So if II equals to 0, this has some current of 1 amps, okay, and this has R, okay. So this is VO. We don't have to calculate that. What is VL this time? So this is VL, right? So minus VL minus 1 times R, and this is also minus no, this is also minus 1 times R equals to 0. So VL equals to minus 2R, right? So initially what was the VL here? Like when this reached 1 amps, I have to draw the circuit. So if I draw the circuit, so let me push this up a bit and reduce the size of this. Okay, so if I draw the circuit here, right? So this is 5 amps. This is some current, right, which is 1 amps, and this is also some current R. So what current is flowing through here? 4 amps, right? So what is the drop? 4R, right? So 4R VL equals to this 4R minus this R. So VL is 3R. Suddenly, now we see the charging rate is more than the discharging rate, right? So obviously it will reduce. Okay, it will reduce, but not to charging rate is this, and initial charging rate was this, right, 5R. So obviously it will reduce, not to that much value. To what amount will it reduce? So IL will go from 1 to, let's say, 0.5 amps. Okay, it goes from 1 to 0.5 amps. Now let's do it for the next case, right? See, when again I equals to 5 amps. So if I equals to 5 amps, right, this is 5 amps, this is the resistor, this is, what is this? This is 0.5. okay, this is R. Okay, so basically now what will happen is, let us find the VL. So what is VL? This is 0.5, right? This is 4.5 amps. So 4.5 times R equals to 0.5. This is 0.5 amps of current, right, plus VL, right? This is basically the KVL through this. Okay, So what is VL? VL equals to 4R. So VL reduced, right? VL reduced, right? So VL has reduced. So what will happen? Basically, like charging rate has reduced, so it will charge from 0.5 amps to something 1.25 amps. Obviously not to 1.5 amps, because previously it got charged total 1 amps, right? So now it won't get charged to 1.5 amps. So again, like the same case, again when the D case, right? Let me shift this up a bit. D case, right? When we have like this II equals to 0 amps. So if II equals to 0 amps, this is R, this is 1.25. So what is this right now? VL right now. What is this VL? So current is flowing like this, right? Like this. So I will apply KVL like this only, anti-clockwise. So plus VL plus this 1.25 R plus 1.25 R equals to 0. So VL equals to something negative minus 2.5 R. So previously it was 3 minus 3 R, right? Previously it was minus 2 R, so it is minus 2.5 R. So it is increasing. Charging and discharging, like charging is reducing, discharging is increasing. So at steady state, what will happen? How the circuit will look like? At steady state, we have this current source II. This is the resistor, this is the inductor, and this is the RL. So at steady state, what will happen? Basically, this is IR and this is IL, right? So IL will reach to some constant value and VL will be 0, right? VL average will be 0. So II equals to IR plus IL, right? Now what is this VO? VO equals to IR times R, and also what is VO? VO equals to IL times R plus VL, right? Now if I put this R value, now what is IR? IR equals to IL plus VL by R. So if I put this IR value up there, what will happen is basically this II equals to IL plus VL by R plus IL. So this is basically what we are getting. So if I add like these two, right? So 2IL. Now if I take the average, right? If I take the average, II average equals to 2IL average. 2IL average, right? So IL average will be equals to II average divided by 2, which is 1.25 amps. Okay, so it will be like 1.25 amps, right? So IL average will be around 1.25 amps. So it will repel around that. Why is it happening? Basically what we can see is this is getting shorted, right? So this average current will get divided into these two, so it will be 1.25 amps. So from intuition also you can understand. So next let me draw the conditions, right, for calculating the voltage. First case, right, when II equals to 5 amps. So if II equals to 5 amps, right, if II equals to 5 amps, this is R, this is 1.25, right? 1.25. This is R. So what is the current through here? 3.75 R, right? So the current through here is 3.75 R. So what is VO right now? VO is 3.75 R. Okay. Sorry, this is only 3.75 and VO is 3.75 R. Okay. Now what is IO? IO is same only, 3.75 only. Okay. But what is happening? So this 5 amps of current, right, this will charge this, this will charge this source, so that it reaches to 2.5. Obviously it won't reach there. So the current through here is increasing, the current through here is decreasing. So if current through here is decreasing, obviously VO will reduce. So what I can say is that IL is increasing, so IO will reduce and VO will also reduce. Okay, so this will be the first case. Now for the second case, right, where II equals to 0 amps. So if II equals to 0 amps, right, so II equals to 0 amps, this is 0, this is R, this is again 1.25, this is R, right. So this is R. So now what is happening? Now what is the IO? IO is minus IL right now. So IO is minus 1.25 R, also sorry, minus 1.25. VO is also minus 1.25 R, right. So like this is the VO and this is the IO. But what is happening? It is discharging, right? IO is reduced, IL is reducing. As IL is reducing, right? So IO will also reduce, hence VO will also reduce. It will try to go to a 0 volts, right? So let me plot the waveforms. So what is happening? VO initially is 3.75 R, right? Initially it is 3.75 R, then it reduces, then it goes to minus 1.25 R, then again it reduces. This is how it will go on. Okay, this is how it will go on, and like it will be same as like this current only. Okay, so here like this is 3.75, this is minus 1.25 R, this is 3.75 amps, this is minus 1.25 amps. So this will be this, this will be this. Okay, so like this is basically the plot. Like what we can say is like what is the average value of this? It is like 2.5, right? So like as the average value is 2.5, so what is happening here is the average like value of this current is 1.25 R, right? So average voltage is 0, so what is the average value of this? This is 1.25 R. Okay, so here if it is 1.25 R, so this should come out to be 1.25 R. Sorry, I meant it wrong. So the average value of this is 1.25 R, right? So how can we calculate this? This is basically 3.75 R times 1 by 2 plus minus 1.25 R times 1 by 2 divided by 1. This is basically T and T. So what is it coming? It is 2.5 by 2. So I like meant it wrong there. It is 2.5 R by 2, which is 1.25 R. So the average voltage is 1.25 R. Okay, so that's what basically we are getting. It is getting shifted, right? This VL is 0, but this is getting shifted due to this 1.25 R like a current drop. There is a drop, right, through this resistor. So like that's it. Now let's go to the second case when T is much greater than L by 2R. So when T is much greater than L by 2R, what is happening? So let me draw for the initial case, right? We have this 5 amps of current. Obviously this is a resistor, this is open circuit, this is a resistor, so this whole 5 amps will flow through here. This is VO. So what is VO? VO is 5 times R, right? And obviously this is VL, which is positive, so IL will increase. Okay, so IL will increase. So what will happen next? So if IL increases, so obviously it will reach steady state. And what is the steady state? This is the case A, right, when II equals to 5 amps. So if IL reaches steady state, this is 5 amps, it will go to 2.5 amps, right? So like IL of this is at T equals to 0 plus, this is at T equals to T on minus. So IL goes to like almost like it almost now it reaches 2.5 amps. So what is the like IO also IO here initially is 5 amps. This is IL 2.5, so here IO will be 2.5 amps also, and VO will be 2.5 times R. Okay, Now let's go for the next case. Next case is II is 0 amps, right? So if II is 0 amps, this has some current, right, which is 2.5 amps, right? 2.5 amps. This is VO, and what is I, right? What is IO right now? IO is negative of IL, which is minus 2.5 amps. Okay, and like what is VO? VO is also minus 2.5 times R. Okay, so VO and IO we have got. So let me calculate the VL here. This is basically the VL, right? So what is the VL? So applying KVL plus VL plus 2.5 R plus 2.5 R equals to 0. So VL comes out to be minus 5 R. So VL is minus 5 R. So basically what is happening, it is like discharging. Obviously VL is negative, so IL will reduce. Okay, so how will the plots look like? Let me draw the plots here. So here what is happening to VO, right? VO, like initially it is 5 R, then it is going to 2.5 R, then minus 2.5 R, then it is going to 0. So initially it was like 5 R, then it went to 2.5 R pretty quick, then it went to minus 2.5 R, then it went to 0 pretty quick, right? So like this will be the plot for this VO, right? So again, but 0, okay, minus 2.5 R, 5 R, 2.5 R. Okay, so and IO is just same only, right? Same only. Increases, changes, right? So this is 5 R, and this is like T on, this is like T. Okay, so this is basically the case, like waveforms. Now let's check for compression again. If we compress this, right, are we getting our like plots? So if I compress this, initially what was happening, it was decreasing, then it increased, suddenly change. Okay, here decrease, sudden change, then increase. Okay, so basically that's what this waveforms are. So that's it for this question. Let's go to the next question. Okay, we have the next question, which is like similar to like previous question only. Basically like we're taking the like output voltage from this R and L instead of this R, right? So one thing we can do, we can apply again source transformation, or we can just solve it like previous only. So or also one thing we can do from previous like question, we can take the analogy, right? So this VL of average will be 0, only this VO of average will be I times R. All those things I hope you know, like intuition approach, I hope you know. I will here use like the source transformation to like solve this quickly, okay, because this video has already gotten so long. So like let's use source transformation, right? Source transformation. Okay, so what will be the source transformation? Basically convert it into voltage source, II times R, this is R, this is R, this is L. Okay, so just be careful when you are like using source transformation, right? Just that the wherever you are measuring the current and voltage, those like should not change, right? This and this should not change. Here like this and this VO is remaining same, only this part is changing, so that's okay. So just be like be mindful of that. So this is R L. So what will happen in this circuit? Basically this voltage source initially this will give 0 current, then at steady state this will be I into R divided by 2R, so it will be II by 2. So I am going to directly to the solution, that is what is this voltage source, right? Let me apply KVL. Applying KVL, right? II times R equals to this IL times 2R plus VL. Now taking the average across both of this equation, average equals to IL average times 2R plus 0, as VL average is 0. So IL average equals to II average by 2, that is 2.5 divided by 2, which is 1.25 amps. Okay, so IL average is 1.25 amps. Now let's calculate the conditions and the output voltage. So for the first case, right, case A, when II equals to 5 amps, basically what do we have is, this is plus minus 5 times R, this is R, right, this is R, this is inductor, this is R, and this is V, right? So right now I should replace the inductor with a current source, right, as the average current through this is 2.5 amps, right? 1.25 amps. Average current through this is 1.25 amps. So what is the VO right now? Basically, if I apply KVL, 5R plus 1.25 times R, this is plus, this is coming in minus, this is plus, and this is plus, VO equals to 0. So VO equals to 5R minus 1.25R, that is basically 3.75 times R. This is VO, right? And IO is basically 1.25 only, right? So VO is positive. What is VL? So basically we know this is charging the inductor, so VL will increase, right? Still we will find it out. This is VL, right? So what is VL? So if I apply KVL again, VL minus 5R plus 2R times 1.25 equals to 0, right? So VL equals to 5R goes there, and this 2 times 2.5R, right? 2.5R. So we can see VL is positive, so IL increases, right? So if IL increases, obviously it is charging, so slowly IL will increase, IO will increase, but what will happen to VO, right? So VO, what is VO? VO is basically I times R plus VL, right? So we are assuming I to be constant, so VL is reducing as it is reaching steady state, so VL reduces, hence VO reduces, so VO will also slowly reduce, okay, but IO will increase, okay. So this is what is happening. Now let's draw for the second case, right? Case B. Case B, what is case B? When II equals to 0 amps. So if II equals to 0 amps, this is getting shorted, this is R, this is R, this is a current source 1.25 amps, and this is R, okay, and this is VO. So what is basically IO right now? IO is again same 1.25 amps only. What is VO? So VO, right? So VO is this drop, right? Drop across this resistor. So VO plus is coming over here is minus 1.25 R. So VO certainly changes from plus 3.75 to minus 1.25, right? So it certainly changes there. Now what is happen to VL, right? What is VL? So this is VL, right? So VL will reduce, right? Basically it is discharging source free network. So what is VL? VL equals to minus 2 times 1.25 R equals to minus 2.5 R. So VL is reduced, so IO will reduce, hence what will happen to VO? Again, what is VO? VO is again minus IO times R, right? So if IO reduces, VO also reduces, right? VO also reduces. So VO again will reduce towards going towards 0 value, right? Going towards 0 value. So let's plot the waveforms. So how will VO look like? So here if we see, right, VO initially is here, if VO initially is 3.75, then VO goes to like minus 1.25 and it reduces, right? So VO 3.75 then minus 1.25. I should scale this a bit better here. If I go it down up a bit, 3.75 then minus 1.25. Okay, so like this is VO, this is 3.75 R and this is minus 1.25 R. Okay, so like this is the VO. What is the average voltage of this VO, right? VO average equals to 3.75 R times T by 2 minus 1.25 R times T by 2 divided by T. So it comes out to be 2.5 divided by 2, which is 1.25 R. Okay, like why is it? Basically, what is VO? VO is IO times R plus VL, right? So VO average equals to IO average times R. So we are getting that only, right? Cross verifying it. Now what is IO? IO is initially IO is 1.25. Obviously it will depend on 1.25. What is happening to IO? IO initially is charging, as like IO is increasing here and IO here is decreasing, right? Source free network. So it will repel around 1.25 volts, right? 25 amps, that is. Let me bring this down a bit. Okay, it will repel around 1.25 amps, right? Okay, this is 1.25 amps. Okay, so this will happen for IO, right? Now this is the waveforms for T much less than L by 2R. Now let's solve for the case where T is much greater than L by 2R. So when T is much greater than L by 2R, let me solve this quickly. So again, like I'm solving this not using source transformation. We have II. So initially what will happen? We have this 5 amps. This is the resistor. This is the inductor. This is VO, right? Now what is happening initially inductor will be open circuit, right? So let me open circuit the inductor. So through here 0 amps of current flowing, through here 5 amps of current flowing. Okay, so like what is VO? VO is 5 times R, right? And what is IO? IO is 0 amps. Okay, this is at T equals to 0 plus, when II equals to 5 amps. Now let's go for the steady state, right? Steady state 5 amps. R, this is VO, and what is the currents through this, right? Basically steady state current will be 2.5 and 2.5. okay, so like what is VO right now? This is at T equals to T1 minus. So what is VO right now? VO equals to 2.5 times R, and what is IO? IO equals to 2.5. okay, so VO and IO, like it goes there only. So now like let's go for the second case, right? For part B, when II equals to 0 amps. So when II equals to 0 amps, let me draw the circuit. This is 0, this is R, and this is R. This is a current source, right? What is this amount? 2.5 amps. 2.5 amps. okay, this is R, and this is VO, right? What is VO right now? Like current is flowing like this, right? So IO is 2.5 only. IO is 2.5 only. This is T equals to T1 plus. So IO is 2.5 amps only, right? IO is 2.5 amps only. But what is VO? VO is like this is plus minus, right? This is plus minus. Sorry, I'm drawing it opposite. This is minus plus. So what will VO? VO will be minus 2.5 times R. okay, so VO will be this. So like VO will go to minus 2.5, suddenly change. Okay, then what will happen at steady state? Everything will become 0, right? Source free network, simply everything becomes 0 or VO 0. Like this is if I at t equals to, this is just small t, I should write this small t, I'm writing this wrong. This is small t, this is t minus this small t. Okay, so everything is 0, right? So this loop 0 amps, so IO is 0 amps, VO is 0 amps, everything is 0. Okay, also like here, like we know that inductor is discharging, right? What is VL in this case? If I like draw the terminals of VL, right, this is very small, so this is plus minus VL. So what is VL? If I apply KVL plus VL plus I times R plus again like 2.5 times R equals to 0, right? So VL equals to minus 5R, right? So VL is basically minus 5R. Now it is negative, right? So obviously IL will reduce, right? Here, like if we see what is VL, like if VL it is charging, we can easily understand in this case, right? In this case, positive VL is basically 5R, right? Plus 5R. And here what is VL? VL is 0 volts. Okay, so this will be the like waveforms. Now let's plot the like output voltage. So initially output voltage is going from 5R to 2.5R very fast, then 2.5R to minus 2.5R, then it is going to 0. So it is going from 5R to 2.5R, then it is going to minus 2.5R, then it is going to 0. 5R to 2.5R minus 2.5R, then it is going to 0. Okay, this is 5R, this is 2.5R, and this is minus 2.5R. Okay, so like this will be the waveform for VO, and for IO, right, IO will be like around 2.5 only. So what is IO here? Like initially IO is 0, right? Then it charges to 2.5, this should be amps, then again from 2.5 it goes to 0. So from 0 2.5, then 2.5 to 0, 0 2.5, 2.5 to 0. So this will happen, right? So like now let's cross verify, right, from like our previous waveforms. So is it happening here? So yeah, if I like compress this, it's reducing, then suddenly changing, then increasing, right? So here what is happening? Reducing, suddenly changing, then increasing. So it exactly follows it. And here also like it ripples, right? It increases, then reduces. Here like if you check, increases, then reduces, increases, and then reduces. So this is basically like I think all the like circuits I have finished, which may be asked in interview. Okay, other circuits are also there which are very difficult to solve, and I don't think they are relevant to you. So I have finished complete pulse response of all the RC, RL with voltage, current source, everything. So like this video took a lot of efforts for me, so please do like share this video with your everyone, with college groups and everyone, so that like it can reach to the maximum people who actually like can learn from this, right? So it took a lot of effort out of me. Okay, so thank you for watching this video so long, and if you watched this video till the end, then go down in the comments below and tell I watched it till the end. Okay, so thank you, and yeah, good luck to everyone. Okay.